A confirmation regarding the audio, please. If you're able to hear me out perfectly well. Thank you. We shall be starting in a couple of minutes, guys. Pratyaksh, generally, no. Other than landforms created by river, generally you won't find questions from the other areas being asked in the mains examination. Having said that, you never know about the unpredictability of UPSC. So it is always advisable to have some idea with regards to the erosional as well as the depositional landforms created by other features as well. Okay, so hello, a very warm good morning to all of you, and welcome to Baiju's exam prep for another session of geography. Now, yesterday we had started taking a look at the portion of the landforms. We looked at the endogenic and exogenic forces overall, and we gained a larger picture of these forces. And then, while taking a look at the exogenic forces, we looked at the various kinds of landforms which have been created as a result of the outcome of these processes. So, whether it is the movement of running water in the form of a river flow, or whether it is the movement of winds from one place to another, or movement of glaciers, or even the action of chemical erosion or chemical weathering which takes place in underground rock layers, all of them are capable to create their own unique form of landforms. And those landforms are so unique that it is not as if a pothole created by a river is something that you will ever confuse with a sinkhole created due to the chemical action. And similarly, a deflation hollow created by the wind is something very different from a cirque which is created by a glacier. So all these are very unique in their own sense of the way. Now, here, one more portion is left, and that will mark the end of geomorphology, and that is the landforms developed by waves. So, here we are going to talk about the action of the sea waves and how they are able to create various erosional and depositional landforms. And then we will proceed on and initiate the discussion for one of the most important units of geography, that is climatology. When we talk about natural levees are a kind of deposits, Biswajit, which happens on the side of the river channel, and it forms a kind of an embankment of sorts. So as the river flows, it keeps on depositing sediments on the sides, and that is how eventually it accumulates to form a kind of a protruded structure, a bulging structure on the side of the river channel. That is what we refer to as the natural levees. Now, here when we take a look at the landforms, you will observe and you have to understand one thing, that when the sea wave they strike the coastline. Now, coastline is not always consisting of the beaches that you generally observe. Beaches that you observe where you have fine sands, etc. In fact, they also are a resultant of depositional feature. You will find that across, especially across the eastern or western coast of India, you will find that there are many stretches where there is no presence of beaches at all. So the sea waves, they have their own mechanical pressure, they have their own mechanical force with which they act. Now, if suppose I give you a kind of a broader representation of, let's say, this is the sea, right? And this is the land area. So suppose here I have certain rocks on the coastline and there is no beach here. Now, when the sea waves will strike this rock, they will in a way provide a kind of a mechanical force. They will be able to provide a mechanical push. At the same time, the sea water is salty. And because of being salty in nature, it will have its own chemical property, and there will be a chemical reaction also which shall be observed, which will lead to further weathering and disintegration of rocks. So that is where, in the case of the erosion or the landforms created by sea waves, you have a combined effect or a combined action of both, that is, the mechanical push as well as the chemical action of the saline and salty seawater. Now it ends up forming very unique kinds of features. For example, here you will be able to observe the formation of cliff, a sea cliff. Now this sea cliffs, these are very large structures in general. What is a cliff in general? A cliff is any upraised portion which has got a steep slope or a wall-like slope going ahead. So that is what you associate with a cliff. In general, when you talk about a cliff, it will indicate or exhibit a feature somewhat like this, right? So this is found across land areas as well. In many of the plateaus and plateau regions, you will come across many of these cliffs, but then they are also to be found across the sea coast. Now, how are they created? So the process of creation of them is again as a result of erosion and weathering. So let us try to understand that process one step at a time. So here, let us suppose this is your land and this is your seawater. Now, when the seawater hits this rock, there it will induce that erosion, it will break the rocks, and slowly and steadily the rocks will start getting eroded from here. Very slowly and steadily, the rocks will start getting eroded from here. It might get deposited right next to it somewhere else, but it will be eroded from here. So as a consequence to it, you will come across a modified rock structure after some time, which will resemble a shape like this. So the seawater now manages to come further inland. Now again, the seawater will exert the same amount of push because it will keep on continuing with the same amount of intensity day after day. It will continue with the same process. So there, again, it will start hitting the base. It will start eroding the base. There is not only going to be the mechanical erosion, but chemical erosion also, which is going to come into place. Now, after some time, you will observe that this landform has been modified by the action of the sea waves to an extent where in this landform you will have a kind of a notch-like feature and the base of it is eroded. And this kind of a feature, again, if you ever are you are an individual who likes to travel, who likes to move around different places, that is when you will explore the most of geography in your life, when you observe your surrounding regions. So if ever you get an opportunity to visit the southern part of western Maharashtra, right, the southern coastal Maharashtra, if you will visit near Ratnagiri and just around the northwards of Goa, and again to the south of Goa in the Konkan coast of Karnataka, you will find you have many such structures with a kind of an overhanging rock portion. Now, after this continues for a long time, or after this is in existence for some time, this rock structure will have its own weight and it will be exposed to weathering action by rainfall, by sunlight, and also By the presence of humidity and saltiness in the air around the sea, there will be chemical processes and chemical weathering in place, due to which this particular rock, you will observe, starts developing a crack. The hanging layer or the hanging portion is the one which is suspended, which is imposing a weight. So this will impose its weight and the hanging portion will simply break down. And now what you have got is a kind of a vertical wall-like structure, right? And seawater might come in till this area, or you might have deposition of sand in this region, creating sandy beaches as well. So that is how these sea cliffs, they get created. And these sea cliffs, they mostly indicate a kind of a sharp fall. And this process will keep on getting repeated till the cliffs gain a kind of a stability. But having said that, there is no certainty that these sea cliffs won't recede back further. And here the creation of sea cliffs overall, you can think about it, that it is erosion carried on by the sea, weathering of the overhanging rocks, and even in erosion and weathering, it is both physical as well as chemical action which is taking place. This image that you see is of the Scottish coastline. Now, there you have large structures made out of limestone. Limestone, as you know, has got significant amount of calcium present in it, and calcium is easily soluble in water. So that is where in these areas, across the coastal areas where you have the presence of limestone, it is significantly easy to create these cliffs, provided you have such structures closer to the coastline. In India, if ever any of you get a chance to visit the state of Kerala, as it is referred to God's own country, it is truly remarkable and truly one of the most beautiful places to visit. Now, in Kerala, I don't know how many of you are aware, there's a place referred to as Varkala. Now, Varkala in Kerala has got remarkable sea cliffs. Now, there you don't have the presence of limestones, but you have the presence of sedimentary rocks in that region. And those sedimentary rocks have been eroded to create a cliff-like structure. So here in Kerala, where do you find it? That is Varkala. Those of you belonging from that region, if at all, would be aware of that. Right? That is where you'll find. The image, however, is not of Varkala. The image is of Scottish coastline. Okay? So that is how these sea cliffs, they get created. Just to give you a size and an idea of the magnitude of these sea cliffs, these small dots that you see, these small things, that is the size of the adult grown human. So you can imagine what is the size of these sea cliffs. These are simply humongous and huge for any proportion. All across the Indonesian coastline, etc., that is also somewhere where you will find the presence of these sea cliffs. Now, then after that, we come to spits and tombolos. Now, what are spits and what are tombolos? Now, both of these are depositional features. Both of these are depositional features and are depositional in nature. Now, when the sea wave comes in, goes back, comes in, goes back, this process continues. And the sea, as it is coming closer to the coastline, that is where all the deposits that it is bringing along with it, maybe the sedimentary deposits, mud, etc., all of that, as the speed of the waves they slow down when they come closer to the coast, they will start dropping and depositing materials. Many of the times you will observe that these sea waves, they end up depositing materials in a kind of a fashion which is perpendicular to the coastline, which is parallel to the coastline. you will observe the deposition of sand parallel to the coastline. Now, these features that you see, where you have a parallel deposit to the coastline, which is created by the sea wave action, but it is not at the coastline per se. This is what we refer to as bars. Okay, these are deposits parallel to the coastline. To the coastline. Now, sometimes these deposits, they happen in a situation where the coastline has got a projection. It is not always the case that the coastline will be in a straight line and water will come in a straight line, will go back in a straight line. No, that is never the case. The coastline or the shoreline will have its own indentures, its own irregularities, isn't it? So sometimes imagine a situation where the coastline or the shoreline, if I give you the top view, imagine that it has got a feature like this. Let's say this is the shape of the coastline. And this is the portion here, which is the sea. Okay. Now, in this case, as the seawater comes in, the first point of contact overall will be the portion which is protruded, this area. If you can look at it, this particular area, that will be amongst the first point of contact that the sea makes. And that is where it will start to deposit sand. It will start to deposit the sandy materials that it has been carrying. But another thing, all those of you who have visited the coastal areas or maybe seen in the movies or in the videos, one thing that you would have observed for all the cases, there is always the movement of wind which happens across the coastline. And in many of the cases, the movement of wind is very, very strong. I'm sure most of you will adhere to this fact and will basically advocate this fact that this is true. So here, in this coastal region also, you will always experience the presence of heavy movement of winds. Now, in this situation, imagine that there is a wind movement, horizontal wind movement, which is moving parallel to the coast. So, wind movement which is parallel to coast. Now, the sea is trying to deposit the sand and the wind is continuously moving in a particular direction. So, this wind will also alter the direction of the wave flow in a way, because if I ask you, this wind, its intensity will be higher or smaller, you have to consider the fact that whether the wind is facing any obstruction while coming to here or whether the wind is moving in a flawless manner without any resistance. If at all it is experiencing any obstruction, its speed will slow down. Otherwise, its speed will continue and carry on the momentum. So in this case, what will be the wind speed? It will be very high. So again, the waves, they will slightly change their directions. Earlier, if you would have observed the waves coming in, earlier the waves would have simply followed this particular path, right? But now, because of the wind movement, the waves will start following a kind of a staggered portion where the wind is carrying the water in its direction. Now, when the wave water in itself is carried in a different direction, what about the deposits? So, the deposits that will be carried or the deposits that shall be made, those deposits shall also be tapered. Those deposits shall also happen according to and along the direction of the wind. So here, if you think about the deposits will happen in a manner which is oftentimes in the direction of the wind, right? Now, that is how the deposits will happen. These kinds of deposits, which are caused or created parallel to the coastal area in the angle or along with the movement of wind in a particular motion, that will create deposits which are parallel to the coastline, attached to the coastline, and extend in the direction of the wind movement. These deposits are referred to as spits. These are referred to as spits. Okay, so that is what we have as a depositional feature in the form of spits. Again, and this is again something that you will be able to find if you visit the western coast, not so much across the eastern coastline. That is why I always say that eastern coastline is quite in a way mundane. If I cannot use the term boring, it is quite mundane. It is something which is very similar, be it whether you go to the Puri coast or whether you go to the Chennai coast. It is something which is very similar. It is only in certain areas around Vishakhapatnam, around the south of Tamil Nadu. Only there you have certain variations which are present in eastern coastline. Otherwise, it is very same, very simple. Western coastline, on the other hand, will have a lot of geographical features and is very, very unique. So there, if you visit the western coastline, you will come across the fact that closer to the coastline, oftentimes you have small islands of sort, very small island. Now, the sea wave action that will happen around this island, that will start depositing materials. And where will it deposit materials? Where the speed is the slowest. Where is the speed slowest? So when they will hit the island, or not a large island I'm talking about, but it will be a kind of an obstruction to the sea movement. So when it will hit the coastal area, it will start depositing certain materials here, where the speed of water will be almost negligibly slow. And these deposits, over a span of multiple years and many years, these deposits will be able to join this island to the mainland in the form of a sand path of something. So here, this is the deposit. Just like here you see the island structure, right? And you observe that there has been a deposit which joins the island to the mainland now. Now, once the deposit joins the island to the mainland, you cannot call it an island anymore. What is an island? Island is something which is surrounded by water from all sides. But in this case, it is not surrounded by water from all sides. It is, but there is that tiny path connecting it to the mainland. So this is what is referred to a tied island. TIED, something that you tie it up, right? You tie something up with a rope or something like that. So this is what is then referred to as tied island. And this depositional path that you observe, this is what is referred to as a tombolo. This is what is referred to as a tombolo. Okay, so that is how you have the formation of spits and tombolos, which are generally observed. Now, this is the example. So for example, here you can see the deposits, they extend outward into the sea, but they have a kind of a depositional feature which is very, very much parallel to the coastline, as you can observe. This is parallel to the coastline almost. In many areas such as United Kingdom, you have certain of these spits which can extend for 17, 18 kilometers long. So that is what you have as the presence of these spits. Okay. So these are referred to as spits. Then observe this. Here, you will observe that there is a kind of a small island of feature, but it is joined by the mainland by this sandy deposit. So this deposit that you observe, this is what is referred to as Tombolo. Okay, that is the kind of deposit which we refer to it as a Tombolo. Now, then when we take a look at a set of landforms, erosional landforms created by the sea wave. Now, here you will observe that if you analyze this image carefully, one by one, spits and bars are not the same. How can both of them be same? In the case of bars, do you observe a join with the coastline or the mainland? No. So this is a deposit parallel to the coastline, but it is not joined to the coastline. In the case of a bar, in the case of a spit, it is always joined to the coastline. This is what your spit is. These are what your spits are, right? So that is why it is different. Why the wind movement is strong in coastal areas? Think about it. Where is it that the wind movement will be strong? Where there are obstructions in the way or where there is no obstruction in the way? If I have many buildings in the way or many trees in the way, will the wind movement ever be strong? The wind will experience a force of opposition. So that is where the wind movement is weaker. But in the coastline, the wind does not experience any kind of a resistance. There is nothing opposing the direction of the wind. So that is why they are persistently stronger. Okay. Now, here we come to certain features which are created across the coastline by the sea wave action. So, for example, when you have the sea wave which is coming in, so many of the times, depending upon the chemical properties of the rocks or the chemical properties exhibited by the rocks, many of the times the sea waves are able to erode materials both by chemical action as well as physical action. And there, once the materials are eroded, that creates a long cave like structure in that place. So that leads to the creation of a very long cave like structure. Now, it can also happen that further more dissolution of materials and creation of more solution might lead to a scenario where the water enters the cave from this side and finds an exit from the other side. So then it won't any longer be referred to as a cave, but a kind of a passageway for water. And that is what we refer to as an arch. So the arch that you see in many of the buildings in the architectural form, you will find the presence of these arches. In the main lobby or in front of the veranda, you will find that there is a kind of an arch-like formation, right? Where generally if you go to a hotel and you will find these are the areas where you park and so on. So that is the arch which is created when the sea wave is able to corrode from one side and simply go to the other side. Now, in this case of an arch, there is an overhanging roof, a roof which is hanging from above. Now, this roof, the rocks which are present and which constitute this roof, those rocks, they are also exposed to weathering action. They will also be exposed to the chemical processes because there will be humidity in the air, salinity which is present. So, these rocks, they will start to weather. And eventually, when the rocks will grow weaker, what will happen? You will find that the top portion simply disintegrates. top portion disintegrates and breaks. Okay, and it falls down. So when it breaks, then after that, you are left behind with this individual pillar, which is slightly away from the coastline. So that is what is referred to as a stack. An individual pillar left behind once the roof of the arch collapses, that is what is referred to as a stack. And over the period of time, as the time passes on, this stack will also weather down. This will also further disintegrate into smaller pieces. And that is when you will observe that eventually it is reduced to a significantly smaller mass, and that is what we refer to as a stump. So all these, that is stacks, stumps, caves, arches, etc., all of these are created as a result of this particular action which takes place. Okay. A76 at Antarctica, it cannot exactly be referred to as an arch. A76 is the name of that iceberg. I hope that is what you are referring to. So it is not exactly an arch, but yes, you will find in the region of Antarctica many of these arch-like creation. But that is largely because of melting of ice. That is not because of erosion, right? And that iceberg has separated. It is moving slowly and steadily. It is moving into the Southern Ocean. So that is why I don't refer to it as an arch. Okay, wave cut platform is basically when you have this standing structure. Imagine a large standing structure, right? So the sea waves will continue to hit at the bottom, and slowly and steadily they will in a way erode the bottom as well, and that is how they create a kind of a platform like shape. Some materials will be deposited here as well, and it will create a kind of a sandy area around it as well. So that is a wave cut platform. So that is what constitutes your actions taken by the sea waves and the landforms created as a result of the process. Okay, and that finishes our portion of geomorphology. Now we come to the portion of climatology, right? Now, climatology, to put it very bluntly and very simply, it is going to be the most important unit in your entirety of geography. Okay. Every year in prelims as well as in mains, you will definitely find a question appearing from climatology. And here you will find questions which are conceptual in nature, which will check your concept. The questions will not be bookish in nature. For in geomorphology, you will still find bookish questions. Bookish questions, by bookish questions, what do I mean? That an explanation is there in the book, from that a question is picked up directly. For example, if someone asks you that what will happen when the plates converge, that is very much a bookish question because that is what you have read. If someone asks you that once the oceanic plate subducts, there is a formation of an oceanic trench, true or false? True, because it is a very straightforward question. So bookish questions you will find to be asked from the portion of geomorphology and oceanography. In the portion of climatology, you'll find conceptual questions to be asked. And UPSC wants to check whether the candidates, they are sure that, for example, if a wind is moving in a region, why it is moving. If a wind is moving in a particular direction, why it is moving. So those concepts are going to be tested quite significantly. If there is a temperature which reduces as you move up or as you move down, why does that happen? So that is where UPSC will check your concepts, will prod for your concept significantly. In climatology, just to tell you the entire coverage that we will go for. So climatology is something we will approach in a step-by-step manner. Each of the step will lead to the understanding of the next step. So here we will be studying the portion of atmosphere and temperature first. Atmosphere and temperature, first of all. Then after that, we shall be studying the portion of pressure and winds. wind movement as well, right? Then here we will be studying types of winds. Then after that, we shall be taking a look at the portion of humidity and precipitation, where we'll take a look at the features such as why the rainfall occurs, how is it that cloud formation takes place, why is it that thunder and lightning occurs, why is it that sometimes even in the summer season you experience the formation of or the ice which falls in the form of hail, right? So that is also something we will study: hailstorm, thunderstorm, everything we will study here, fog formation, humidity and precipitation. Then after that, we will be looking at the portions of air masses. It is not snowfall, Shruti, it is something different. That is why we need to study that, because many of the times you will find, thankfully, if you are not on social media, you are isolated from these kinds of nuisances. But on social media, you will always find people immediately reporting that there was a snowfall in Delhi, there was a snowfall in Noida, there is a snowfall in Madhya Pradesh, there is a snowfall in Telangana. That is not snowfall. In India, snowfall happens only in Jammu Kashmir, Himachal, parts of Uttarakhand, Sikkim, and parts of Arunachal. That's it. Only in these states will you experience snowfall. In all the rest of the states, if there is ice which is falling, it is not snow, it is something very different. Okay. Now, sweetie, is it a live session? Think about it. Let me know if it is a live session or not by the end of the class. I think that will be enough time for you to decide whether it is live or not. And cyclones, different types of cyclones. Okay. Now, after that, we are going to study the features of or certain atmospheric phenomena. For example, El Nino, La Nina. Okay. We are going to study about Indian Ocean Dipole, jet stream, and global climatic classification. That what is the climatic condition that you experience in different parts of the world. What is the amount of rainfall? What is the amount of sunshine which is received? All of these portions that will demarcate our journey in climatology. Okay, so right from this is going to be from atmosphere and temperature is the base that we will start from. That base will set up an understanding for the next one: pressure and wind. So wind movement, etc. For example, this is where climatology is particularly tedious for those candidates who find it very difficult to be very regular, right? And this is where it is slightly different from the other subjects as well. For example, let's say you are sitting for a class in polity or in, let's say, history. Even if you have missed what the social reformers did, does not mean that you will never be able to understand what Lord Curzon did. That will be very simple process to understand, because you can think, okay, social reformers I'll read some other time. Even if, let's say, you miss the Swadeshi movement, you'll be able to understand what happened in Jallianwala Bagh, because they are different in a way. In the case of other subjects, if I can give the example, if you miss the portion of union legislature, does not mean you will never be able to understand the powers of the president, right? So that is how in all the various subjects you get a kind of an isolation. In the portion of geography, particularly in climatology, there is a flow. If you are unable to understand the portion of variation of temperature, the movement of the winds will be difficult to understand. And if these two are not clear, why is it that it rains in certain areas and not in other areas, that will be very difficult to comprehend as well. And if these three portions are unclear, you will never be able to understand complicated concepts like cyclones and why the cyclones occur. And if all these things are not clear, then basically El Nino, La Nina, Indian Ocean dipole, jet stream, that is something which you can forget about. So each of the concept builds upon the next. So that is why I would tell you that please, in the case of climatology, follow a step by step process. Once you leave out a chunk of the portion, it will be almost impossible for you to understand the next. Having said that, there are going to be areas, few of the nooks and corners where you might find it a bit difficult on a side to understand. Don't worry about it. Don't lose your calm over it. At the end of it, you might be able to look at the larger picture provided you are patient enough. Be patient enough, try to grasp in the newer things, because I'm sure for many of you, the concepts that you are going to read here, that will be for the first time your initiation to the outer world concepts of climatology. Many of you would not have studied the climate in such greater detail. So that is something that we are going to do here. So that is why pay significant attention. Now, when we talk about it, basically, this portion of atmosphere and temperature, this is going to be relevant at for the prelims. Frequently questions are asked from here, and the mains examination. So in prelims, you get questions with regards to the components of atmosphere, what constitutes the atmosphere, then structure of atmosphere, atmosphere, layers which are present. Then after that, you get questions from distribution of temperature, then temperature inversion. Now, once that is in 2018 and 19, UPSC had also asked a question with the perspective of evolution of atmosphere. That is again something that we are going to cover, how the atmosphere has come into existence. The present day atmospheric setup that we see, it has not always been like that. It is something which has emerged recently, in the not exactly recently, but around few 100 million years back. That is how the atmosphere has shaped into. For the mains examination, you get questions for layers of atmosphere, you get questions from urban heat islands, then temperature inversion, so these are the areas from where frequently questions are asked. Even in this year, that is in 2022, you had a direct sort of question, very simple question, which was asked from this particular portion. It was taken, or if you think about it, that is something which is present in the PPT as well. And the question was very direct, that what are the features of troposphere? So you get a very direct sort of questions being asked from this area in general. Now, why is it that UPSC pays so much attention to climatology? Does it expect you to become climate scientists at the end of the day? That if somehow you are unable to clear UPSC, you will become a meteorologist in Indian Meteorological Department? No. Clearly, that is not the aim. That is not the goal. The goal for setting so much of importance or priority to climatology is very simple. The climate around us is the most important determinant of how we lead our lives. From the types of houses that we live in, to the architecture that our buildings will have, to the food habits that we inculcate, to the dress that we wear, to the occupation that we pursue, in many of the cases, to the social structure that we observe. Everything is driven around by the climate. How? For example, take the case of the building. Take the case of building architecture. Now, the building architecture that you observe in the areas which receive snowfall, you will always find the presence of a kind of a sloping roof. Even in art and culture, when you will study the temple architecture, you will study that the temple architecture, particularly in the region of Jammu Kashmir, Himachal, etc., that always has a kind of a sloping roof. Why? In order to withstand heavy snowfall and in order to provide stability to the building so that the snow simply moves away. But such kind of a structure you won't find to be in existence in the region of the central India. Again, you go to the region of Kerala. In the region of Kerala, you are frequented by rainfall, very heavy rainfall. And I hope we are aware that Kerala is also the region where you will find India's first mosque to be built, right? I'm sure that is something you would have read as a part of your general knowledge or general awareness, that it is the area where you will find the India's first mosque which was built. Now, even in that, if you observe the architecture, it is very unique. It is unlike any other building that you will see. And that is again keeping in mind that the Kerala coastline will receive a heavy amount of rainfall. So if you have a flat roof, water will accumulate, water will weaken the roof, and that will never be lasting. So you have sloping roofs. So that is where the architecture, the building that we live in, determined by climate. The economic decisions that we take in the real world scenario, if you have to associate with it without going into the past, in the real world scenario, observe the kind of panic that the entire European region is in, especially during the months of November, December. They were panicking. Why? Because the climatic conditions are so cold that they need heat. And that heat they get from where? By burning the fuel, by burning natural gas, oil. Where do they get that oil and natural gas from? From Russia. So that is where economic decisions overall, strategic decisions overall, many of the times are directly or indirectly facilitated by the climate. The food that we consume in India, we have a variety of dietary habits from north to south, east to west. We have a variety of cuisines, right? And here we have plant-based diet. Significant amount of vegetarianism is something that you will find across the regions closer to the equator. You have a lot of fruits which are present, and generally you have, for example, in many areas, rice is consumed throughout, and that is because of the climatic condition. In the region of Northern Europe, it is almost frozen for 4 to 5 months of the year. They cannot grow crops. So obviously their diet will be more meat based. That is, animal protein is something that they are forced to consume or bound to consume since ages, and now it has become a part of their dietary habit, isn't it? It is not as if that someone 500 years back in Europe suddenly decided that today is high time, from now on, nobody in my generation will eat spinach anymore, and they started eating meat. No, it was a decision largely determined by climatic condition. It is because of this climatic condition that you had the Europeans feeling the necessity or the need to have spices, not to make their food spicy, but the spices to act as preservatives for their food, which could then be preserved for 4 months, 5 months at one end. And where do they get the spices? from the region where the climate is warm. Where are the regions where the climate is warm? Around the equatorial area. So that is when the European powers, they went ahead and colonized the equatorial areas across the globe. And that is why colonialism, again a part of history, driven by climate. Not only this, in history, you will find many such instances where the invaders, the invasion, that in itself is determined by the climatic realities of the place. For example, rather than going back to the era of Babur and so on, take the recent case in the situation of World War II. Now, in World War II, up till 1942, Hitler's forces were advancing rapidly. And you would have read about in world geography as well that, or you would read in world geography as well, that Hitler's forces, when they invaded Russia, they were very close to reaching Moscow, and they fought at Stalingrad, or what we refer to as St. Petersburg. Now, there, when you had this battle, it was the climate eventually which defeated the Germans rather than the Russians themselves. And what portion of climate? The harsh Russian winter. And nobody could be prepared for that. And eventually, that was so demoralizing for the German forces, and so many people lost their lives in that Russian winter. There was no coming back in that area. So, climate has been a major determining factor of the life of everything that we see around us. And for this, you don't need someone to tell you that today this is the climate, today that is the climate which is expected. No. Here, step outside your house, look up in the sky, observe it. Observe the air around you. Sometimes in the air itself, you will feel the presence of some amount of moisture. The air will be cooler. Sometimes the air will be significantly drier. So all these are climatic nuances that you will experience. So that is where we'll study this. So we start with the portion of atmosphere. In this portion, what is it that we'll study? We'll study about the evolution of atmosphere. We'll be studying about the composition of atmosphere. So in this, evolution, composition, we will also be covering few of the very basic concepts. And why we will be covering that? Because we are assuming that, let's say we are not from the science background, or we have forgotten the science that we have studied till class 8th. If I assume that we have forgotten everything that we have studied till class 8th, that is why we will cover basics of heating, and heat transfer. Then we are going to look into layers of the earth, or layers of rather the atmosphere. Then insolation and temperature. No, heat budget we will be ignoring. Heat budget not very relevant if you look at the past few years. Heat budget not very relevant, so we'll be leaving that. You can study that from the book if you want, or from the tablet if you want. And if you have any doubt, always feel free to come to me. But heat budget we will be removing because has not been asked for a very, very long time now. Okay. Then after that, we'll be studying the portion of albedo, urban heat island, also temperature inversion. Okay. These are the areas which are going to be important for your examination as well. These are going to be important and relevant for your further understanding as well. So these are and in this, the basic concepts that we will be studying, these concepts shall be applicable for a long time in the portion of climatology in general. Okay, so without further ado, let us initiate our discussion, and let us initiate the discussion with the evolution of atmosphere. So when we talk about atmosphere, first of all, what do we mean by atmosphere? Atmosphere refers to the blanket of or the envelope of gases along with other materials which is present around us and which envelops and surrounds the planet Earth. So here you will find, if I take you back to this image, you will observe that there is a lighted portion. There is a lighted portion. Now, this is not the surface, by the way, but nonetheless, it is slightly lighted, isn't it? So, this is basically your air which is lighting up because of the sunlight which is coming, because of light reflected from the surface. This is the air which is glowing. So, atmosphere that extends right from the surface to a significant height as well. Now, overall, it is said that the height of the atmosphere is thousands of kilometers above the surface of the Earth. You have some records which claim that you will find gaseous molecules even at a height of 28,000 meter, 29,000 meter, and so on. But does not mean that that is a particular region where you can actually breathe. In fact, the breathable air, the air that we breathe in and breathe out for our survival, that is something that you will find only closer to the ground surface, in the lowest portion of the atmosphere. Now, this atmosphere we breathe in or is a life-giving source for almost all the living beings across the planet. We breathe in, we breathe out. Now, breathing in provides oxygen to our body, very important for our body's survival, right? And we give out carbon dioxide. Now, can you imagine an atmosphere where there is no oxygen which is present? So that was the atmosphere which the planet Earth has had for the majority of its time. Overall, the age of Earth is how much? Close to around 4.5 billion years. The presence of oxygen in the Earth in dominance, that is something which has been felt only for the last few hundred million years. That is around 400 to 500 million years is when you do have the presence of or the significant presence of oxygen. For rest of the history of the planet Earth, oxygen was virtually absent. Okay. Now, here the atmosphere has basically evolved in various different phases. Initially, when the planet was very much a hot molten ball of liquid, at that point of time, the atmosphere consisted only of helium and hydrogen. That is what was referred to as the primordial atmosphere. So, this is when planet was very hot in the initial stages. So, this is when in the primordial atmosphere you had the presence of hydrogen and helium. Okay, hydrogen and helium both were present. Then we have seen in the phase of or in the portion of geomorphology, we have seen that slowly and steadily the surface started cooling down. And as the surface started solidifying, you had gases trapped in the interior of the planet. And those gases, they erupted. And thus came the phase of degasification, when you had a series of volcanic eruptions which happened across the entirety of the planet. I hope you remember that, right? So you had the phase of degasification. Now, this phase of degasification basically meant there was an eruption of significant amount of volcanoes, and hundreds and thousands of volcanic eruptions happening all across the planet. So, huge volcanic eruptions, and that too very frequently. Now, it is after all this volcanic eruption which has led to the presence of water on the planet Earth, right? Because of the release of oxygen, hydrogen, both of them combined to form water vapor that led to the formation of clouds. And that is where we had the torrential rainfall phase, which continued for almost 7,000 to 10,000 years of continuous rainfall, which filled up all the depressed areas across the planet. So we do know that phase of degasification is important. And when you had so many volcanic eruptions, hundreds and thousands of them happening on a daily basis, you had gases which were released, which were new. New gases. Which were these gases? You had the release of ammonia, you had the release of carbon dioxide, you had the release of carbon monoxide, you had the release of H2 and O2 also, which combined and led to formation of water vapor. So vapor was also released. You had sulfur which was released. So these were few of the gases which were released. Now, till this point of time, you will observe that there is no presence of oxygen separately that we see today. Now, over a period of time, things started changing. The presence of carbon dioxide and carbon in the air on the ground surface, all of that initiated the growth of green plants. And around 500, 600 million years back, that is when these green plants and their existence that started dominating. Now, these green plants, they take in carbon dioxide and give out what? Oxygen by the process of photosynthesis. So when the green plants, they were in abundance many 100 million years back, that is when they started giving out oxygen. So here you had the modification of atmosphere due to photosynthesis. Due to photosynthesis. As a result of that, you had the concentration of carbon dioxide starting to come down, whereas the level of oxygen in the air that started to increase. Now, this trend has continued till date, where the level of oxygen has been increasing and the level of carbon dioxide has been reducing. And this was a phenomena which was consistent, good for the various different animal species, etc. But then we humans came in, and that is when this was a kind of a biggest, in a way, bane or a biggest disaster that could have happened on the planet is not the falling of the asteroid or destruction of the dinosaurs, etc. No, the biggest disaster is the onset of the reign of humans. We humans came in. So when we humans came in, we were never happy with the nature itself. So we started developing industries. And since the industrial age, we have managed to slightly put a halt to the entire process, if not revert the process. And since that point of time, the carbon dioxide concentration has started to push back up. So that is where after industrial revolution, the proposition or the proportion of carbon dioxide in the atmosphere has started to significantly rise up. So that is what we have as the phase of evolution. Now, UPSC had asked a question in 2018 prelims. Now, many of the candidates, they were so lost by that question, they had no clue And that is where those candidates, when they come out of the exam hall, they will give you all sorts of opinion that now UPSC has become so unpredictable, it is a lottery system. Why should I waste my life in UPSC? It is asking any question. That person, he had studied only that much, that is why he succeeded. I went to the church, I went to the temple, I could not. So the question, if I tell you, was as simple as oxygen has been present in the atmosphere since its very beginning. That was the simple statement. And if you would know the fact that oxygen has been added up later, you could easily eliminate that statement and the entirety of question would be solved. But then that created havoc and panic. And that is something that UPSC also ends up liking. It cherishes it. It cherishes when the candidates, they lose their grip and they simply start creating a kind of a panic like situation. UPSC enjoys and revels in this. So that is where, please don't do that. Now, here, when we talk about the entire process of evolution, this has taken a long period of time. Today, if you will observe, the gases which are present, the presence of gases and the proportion of the gases, if I can take you to this slide. So you will find that nitrogen is present in the most dominant quantity. Then the second, close second comes oxygen, around 21%. Then comes argon, and then you have carbon dioxide around 0.04%. So, nitrogen is present in such significant quantity where all the other ones, they are changing since that point of time. Now, when is it that nitrogen was introduced in the air? It was introduced here in the form of ammonia. Since that point of time, the proportion of nitrogen in the air has largely remained consistent and constant, whereas the proportion of the other gases around it, that has been changing continuously. Carbon dioxide can be absorbed by seawater, as you would have studied or as you will study in environment as well, that carbon dioxide is absorbed by the trees, carbon dioxide is absorbed by ocean water and seawater, carbon dioxide is taken in by many of the other species, a few of the other species as well. Carbon dioxide reacts with materials, forms carbonate, calcium carbonate, and so on. So that is how carbon dioxide is consistently consumed. When you talk about oxygen, we breathe in, plants give out oxygen. You have the aspect of oxygen being or oxygen reacting with various surfaces, forming oxides very easily. So that number also fluctuates. But nitrogen doesn't react readily. Nitrogen is not reactive. It is not as if nitrogen will start interacting with the surface rocks and will form a kind of a nitrate or anything like that. No. So nitrogen that you see is nitrogen is pretty or inert in nature and does not react readily. So as a result of that, you won't find that the nitrogen is being consumed somewhere significantly or it is getting converted into rock nitrates. It remains as it is, consistent. And that is the case even today. That is why in majority of the rocks also you will find that you will have oxides, you will have carbonates, you will never find nitrates. And the soil is formed as a result of what? As a result of disintegration of rocks. Weathering of rocks leads to the formation of small particles of soil. Now, if the rocks don't have nitrates, will the soil have any amount of nitrogen or nitrate? Obviously not. That is why majority of the soils across the globe, you'll find that majority of the soils across the globe, they do not have nitrogen. And that is why you have so much greater demand for nitrogen based fertilizers such as urea. So that is how you can interlink the property of nitrogen to even the economic implications what it leads to. Okay, CO2 is what? Why, Vijay? Why is what? I mean, I can have the entire lecture and at the end of it I can ask why. So what? Why? Please elaborate your question. Please don't put such questions. Pritam, CO2 is 0.3%, 0.38, 0.39, or roughly taken around 0.4%. Why there is no nitrogen? Kindly type the entire question. Please don't be that lazy. Okay, if you want the answer to the question, please ensure that you are able to type the entire question. Um, Vaishnav, why nitrogen-based fertilizers are needed? Vaishnav, nitrogen-based fertilizers are needed because majority of the soil conditions that you see, the soil is absolutely poor in nitrous content or nitrogen content. Now, why is it that the soil is poor in nitrogen? Now, how is it that the soil is formed? Soil is formed as a result of breaking of rocks. So, if the rocks consist of nitrogen, the soil will consist of nitrogen. But do the rocks consist of nitrogen? The answer is no. Why? Because the nitrogen which is present in the air that is inert in nature does not react readily. So, as a result of that, you will have no nitrate formation in the rocks. And as a result of that, when the rocks break, the resultant soil is devoid of nitrogen. It is the chemical property, Amit. Look at where nitrogen is placed on the periodic table. It is the chemical property due to which it is inert. Shruti, then how we use black soil in agriculture if nitrogen is not present in that soil? See, we are not talking about agriculture right now. I was just trying to give you a kind of an impression of how it is related to the portion of soil fertility as well. But if you must ask that question, let me tell you that even in black soil, you apply urea, isn't it? You apply urea even in the case of black soil. It is not as if that without nitrogen, the plant will not grow only, the plant will die. No, plant will grow even without nitrogen, but it will grow much significantly in the presence of nitrogen. That is why you require urea. Then in the case of alluvial soil also that is poor in nitrogen. Why is it that plants grow there? So that is not the logic here. Okay. Devansh, you had small amount of oxygen and trace amount of hydrogen which combine to form water vapor. Then evolution of oxygen basically, Sachin, can be traced back to the origin of the plant species. And plant species as they came in significance. See, oxygen, it is not as if it was completely absent. It was present in the form of oxides of carbon, etc. But oxygen molecule in the air that we breathe in, that started coming into place once the plants came in. They started carrying out photosynthesis and they started producing oxygen. Okay, if we can make use of nitrogen, then it would be very good for today's problems. Absolutely, yes. Or there will be any problem? No. If there is less nitrogen in atmosphere, does not create much of an issue there. Okay. Now we come to the composition of atmosphere. What is it that the atmosphere is constituted or composed of? So broader classification, if you will observe, then basically you will observe that the broader classification of constituents can be gases, water vapor, which is also a kind of a gas, but it is treated separately because the impact that it has, and the atmosphere is also constituted of dust particles. So these are the various components of atmosphere. Now, each of them, they play their own role. For example, when we talk about gases, they are life support systems, first of all. Be it the availability of oxygen for us, be it the availability of carbon dioxide for the plants, these are your basic life support systems. Then the gases, they also carry out greenhouse effect, or with the greenhouse phenomena, they ensure the consistency of temperature on the planet even during night. So let me elaborate on this a bit. So when we talk about the planet Earth, and we talk about the planet Earth moving around the sun, some portion of it which is exposed to sunlight, that is the one which will experience daytime. The rest of it will experience nighttime. So let's suppose this is the planet and this is the axis. Simply put, let's suppose. Now this is how the planet is rotating from west to east. Now the portion which is exposed to the sun, which is facing the sun, what will be the condition? It will experience heat. It will exhibit a temperature rise, isn't it? Daytime temperature always higher. Now that heat can always be attributed to the fact that yes, it is directly facing the sun. But what if we consider a portion here which is away from the sun, which is not facing the sun? Why is it that even in those conditions, you don't experience that the temperature goes to minus 80, minus 90 degrees Celsius? How is it that we are able to experience that even during nighttime, the temperature is 20, 30 degrees Celsius in the case of India, or in otherwise also around 10, 15 degrees Celsius? Ideally, if the sun is not shining in that region directly, the temperature should drop, should plummet. It should be in the negative zone, but it is not so. In many of the other planets that you will observe, which don't have significant amount of atmosphere, that is the terrestrial planets, you will observe that the daytime temperatures are high, but the nighttime temperatures are very, very low. That is something you don't experience on planet Earth. Why? Because of the phenomena of greenhouse effect. What is this greenhouse effect? Greenhouse effect is a phenomena whereby the incoming solar radiation, which has got very high amount of energy, that incoming solar radiation heats the surface. Upon heating the surface, that heat is released in the form of terrestrial radiation, or that heat basically which is released from the planet, that is trapped by the atmosphere. Some of it escapes into the outer space, but then significant amount of it is trapped by the planet. That is the greenhouse effect. and that allows and ensures the maintenance of temperature in the atmosphere even during night time. Now, I'm sure many of us here, we have no clue about the aspect of radiation or solar radiation or terrestrial radiation. So let me give you a brief background about it. Please always understand anything which is hot, very, very hot. For example, take the case of uh, a bulb, a normal bulb, the yellowish kind of bulbs, the ones which were used in olden days, not the CFLs of today, the olden bulbs. Now you had 40-watt bulb, 60-watt bulb, and so on. Now, even if you switched off the light, you would observe that the bulb got very, very hot, burning hot. And if even if you did not touch the bulb, even if you brought your hand closer, that would bring about some amount of heat in your hand. You would experience some amount of heat in your hand. How did you get that heat? The bulb is here. You are placing your hand here. How is it that you experience the heat without touching? Have you ever thought about it? What do you think will be the reason that the bulb is here and your hand is here, still you are able to feel the heat? Let me know. Yes, Abhishek, significantly correct. Latent heat, Amritansh, is a different thing where a material changes state. Heat energy travels. How? How is it that heat energy travels? By bus, by train, by Ola, by Uber, by auto? How is it that it travels? Convection is where you will observe a vertical rise. So it is not convection. It is radiation. Okay? It is the radiation from that hot bulb. So basically, any object which has got temperature will emit heat, and the heat energy will travel, as rightly pointed out, that yes, Manali had rightly pointed out that heat energy travels, but it travels in the form of waves, right? Or in the form of radiation. That is how even the sun, which is so far away, around 150 million kilometers away is the sun located, but still the heat is felt on the earth. In between the sun and the earth, you don't have the molecules which will get excited and which will come to the earth and provide the heat. You don't have the presence of convective current moving horizontally across and heating the earth. It travels in the form of radiation. Okay, so this basic is correct, right? Very good. All those who have said it correctly, very good. Many of you have given the correct answer. So here, hot object releases heat in what form? In the form of radiation. That is how energy is transferred. That is how energy is given out. Now, hotter object is giving out energy that is traveling in the form of radiation. Now, I give you two instances, two objects. Okay? Two objects. Or in the same object, I will give you two conditions. Condition A is when the temperature of this body is 40 degree, or rather 400 degrees Celsius. And condition B, the temperature is 4000 degrees Celsius. Now, give me an answer in the form of a poll. Out of these two cases, which of them will release greater amount of energy? It should be very simple. Which of these situations will lead to a release of greater amount of energy? A or B? Very good. Still, I have 10 candidates who say that A will release more energy, but it will be B because the temperature is high. So it will always release more energy. Now, energy travels in the form of what? Energy travels in the form of waves, be it light, be it sound, be it heat. Energy will always end up traveling in the form of waves, right? So, energy travels in waves. Now, I will not take you to the depth of the waves. I will not take you to a situation where you will want to virtually kill yourself that why am I studying this subject after all? I wanted to become a district collector and I'm studying about waves. What has happened to my life? So, very simply put, when we talk about waves, waves are of various nature. Now, waves depict the energy which is transferred, the energy which is given out. Now, if I consider the waves, you have various kinds of waves. Now, in this situation, I will take you back to the condition A and condition B. When I'm talking about condition A, the temperature is less. So it will give out waves, right? The waves will be given out. But in the case of B, the temperature is very high. So the energy will be given out more frequently as compared to A, isn't it? So in this situation, when you have more energy, okay, when you have more energy, that is where energy is given out more frequently. Energy is given out more frequently. What does that mean? It means that there will be more pulsating signals very quickly, which will be released from that body. So that releases a kind of a wave which will give you an appearance of, if you think about it, it will give you an appearance somewhat like this. Very frequently, energy is given out. Whereas when the body is slightly cooler, the energy will be given out after some time and the energy will travel like this slowly. Now, based upon the length of the wavelength as it is referred to, the length of the wave is this much. This is the wavelength represented by the Greek alphabet lambda. So, this is the length of the wave. In this case, what is the length of the wave? This is the length of the wave. So when the energy is given out more, that is in a hotter object, the wavelength will always be smaller because it has got more energy. Whereas when the energy is less, the wave will be released easily and you have the long waves. So these are what are referred to as short waves and these are long waves. Yes, Pratyaksh, that is correct. Now, hotter the object, shorter the waves. Colder the object, longer the waves. Okay. Now, when the sun provides energy, sun is very hot, temperatures of thousands of degrees Celsius. So, it will generate what? Short waves. So, the incoming solar radiation, incoming solar radiation will have a feature of what? High energy, short wave. right? Very high energy. Now, this energy is the energy of these waves are so high that they are able to easily penetrate the atmosphere. They reach the Earth's surface, they heat up the Earth's surface. The Earth's surface, when it heats up, it can gain a temperature of 40 degrees Celsius, 50 degrees Celsius, in certain areas, even 55 degrees Celsius, but not more than that. You won't come across a situation on the Earth's surface where the temperature rises more than 55, 60 degrees Celsius at all. So, Earth is also now acting as a hot object or a hot body. And Earth's temperature is 50, 55 at max. So, it will also release heat. But this heat, or it will also release energy, but this energy will be much lower in comparison to the solar radiation. So, that is where, when we talk about these, that is the Earth, when it gives out the energy. So, that is also what is referred to as terrestrial. Terrestrial radiation. Why terrestrial? Because it is released from the terrain or from the surface. So, this will be in comparison what? Very low on energy. Low on energy. And when it is low on energy, that means what? There will be long waves. Now, these long waves that the Earth releases, they are trapped by the gases which are present. They are re-radiated back. And that is because that is what is referred to as the greenhouse effect. And due to that, as the heat is released from the Earth's surface, again it is reflected back, again reflected back. So that is how the planet is able to maintain the temperature even during night time. That is why if you leave your vehicle parked outside in the sun, in the scorching sun, you will observe that during the when the sun is or you leave it out, you park it out, you close all the windows, you come back after some time, you'll observe that the insides are significantly hotter. It is almost burning. And that is primarily because of the fact that the incoming solar rays, they will provide that short wave and they will be able to penetrate the glass, and that penetration of glass and eventual heating of the interior will also start releasing some heat, right? From the inside, some radiation will be released, but they will be in the form of long waves. And those long waves, because they are low on energy, they will be trapped by the glass, further heating the interior of the car. So, something very similar happens in the case of the atmosphere as well, where the terrestrial radiation is trapped. That is another reason why you will observe that during the nights when it is cloudy nights are always going to be warmer as compared to clear sky. Because in the case of the cloudy night, those long waves which the earth emits, that is reflected by the clouds and re-radiated back to the surface. So that is when you will observe that there are a lot of clouds. You will feel, and many of the times it does surprise us, because what do we expect? Now that the cloud cover has come, it will be very cold, very, very cool and pleasant. But sometimes you would have found out, you would have experienced that despite the cloud cover, now you are perspiring or rather sweating more profusely. So that is because of this heat, or which is re-radiated. Okay, that is the aspect of greenhouse effect, and that role is played by the gases which are present in the atmosphere. Then you have the presence of water vapor as well. Now, if I talk about the presence of water vapor, it is not as if water vapor is present in the entirety of the atmosphere. In fact, the concentration of water vapor is restricted very much to the lower levels of the atmosphere itself. Very lower layers of atmosphere, that is where you will have the concentration of water vapor. In fact, almost around 90% of the water vapor in the atmosphere is restricted to a height of around 5 to 6 kilometers above the surface. So, how much water vapor is present? So, there you have a very interesting kind of a research paper which tells you that if all the water vapor that you find in the atmosphere, if by some event or action of the god you are able to convert all that water vapor into liquid water, that would manage to cover the earth in a layer which is only around 1 inch thick. So that little amount of water vapor is present. But then this water vapor, which is present in the atmosphere, gives rise to climatic phenomena, first of all. All the climatic phenomena, from rainfall to fog to mist to cyclones, all of them, El Nino, monsoon, everything is determined by the presence of water vapor in the air. Then, here, by the way, in desert areas, the presence of water vapor in the air, that is used by certain organisms to fulfill their requirement of water. It does not rain in the desert areas, but nighttime it becomes so cold that there is formation of fog, and fog is when water vapor is present in condensed liquid form in very small proportions. So many species of frogs, etc., directly from their skin they start absorbing that water vapor, fulfilling their bodies. So water vapor is also significantly life giving. Then the water vapor traps the terrestrial radiation and maintains heat. It starts acting like a greenhouse gas. That is why. How is it that you get to know that it is going to rain? It is one of the important indicators that you find clouds very often. That it is cloudy, someday it will rain, someday it will not rain. It has got a mood of its own. But there shall be few of the cloudy days when you step out and you feel that it is cloudy, but it is very, very hot, right? You can feel that kind of a heaviness in the air. So that is when you will start perspiring. The sweat will not evaporate as well. It will stick on to to the surface of the skin. That means there is an abundance of water vapor, and that is what is trapping the heat. And whenever that situation comes, take shelter, because it is going to rain very heavily and it is going to rain for some good duration. So that is how water vapor is relevant to us. Then, after that, we have the presence of dust particles as well. What are these dust particles? The suspended particles in the atmosphere. Now, these dust particles, they also play multiple role. We oftentimes refer to them as pollutants, but they also play multiple roles here. So what are the roles that they play? First of all, if you take a look at it, they scatter and trap light. Okay, so the dust particles which are present in the atmosphere, yes, Amit. So they scatter the light. They trap that light within themselves. Now, what will they do after accumulating so much amount of light? That is what allows you to look even during the dark, in absolute pitch black night as well, when there is maybe no moon, no street light, right? No other artificial light which is coming. Still, if someone puts you or makes you stand out in the middle of the road, it is not as if you won't be able to see, or you would be able to figure out that, okay, this is a road, that is a tree, etc., etc. That much amount of detailing you will be able to make out. Why? Is it because you have a special sense that you are able to see in the dark? No. The light which has been trapped during the day, that is what is given out. And that is what is referred to as a diffused light. So this is what is given out is diffused light. As diffused light. And allows us to see in pitch dark conditions. Okay. Now, that is not the only role, by the way, which the dust particles play. The rainfall that we receive, rarely do we realize that that rainfall would not have happened if there would not have been a dust particle. How? So, we will take a greater or a deeper look into the formation of clouds, how the clouds get created, etc. But basically, what are clouds? These are condensed form of water vapor. Water vapor rises up, cools down, forms liquid droplets, forms clouds, falls as rainfall. But where is it that it will condense? How it will condense? So these dust particles provide them a platform. They will provide a surface around which the condensation of water vapor into liquid water droplets that takes place. And that is why they are very, very instrumental for the formation of clouds. So these dust particles provide a platform for cloud formation, or rather, simply put, for condensation, and that leads to cloud formation. They effectively are able to provide what we refer to as a nucleus, right? The nucleus around which everything is present. So they are able to provide that kind of a nucleus. So that is why the dust particles, they are also what are referred to as hygroscopic. It is not hydro. So all of those who are concerned that I am committing a spelling mistake, which I do in many of the occasions, but this is not the occasion. So hygroscopic nuclei. These are the ones, or these are those particles which attract water, which allow the water to stick to the surface. So these allow the vapor to stick to the surface. You also have certain particles which are referred to as hygrophobic. So water does not stick there. So in those, no condensation will happen. But dust particles in general, they provide that kind of a platform around which condensation can easily happen. Okay. So that is the composition of atmosphere and the greenhouse effect that we have looked at. We have looked at terrestrial radiation, incoming solar radiation, greenhouse effect, and the role played by each one of them. Then after that, we will move on to the modes of heating. But before that, we'll take a break. So how long a break do you want, guys? Let's be democratic about it. Hmm. I mean, just because I give you the freedom, you will ask for anything, isn't it? Why only 30 minutes for breakfast? Why only will you prepare for yourself? Prepare for others as well. Feed everyone. We'll meet at 9. Shruti, I agree with you, my dear friend, but sadly we are in minority. So take a break, relax, get back, and we will talk about the rest. See, climatology, it can be very burdensome if you are simply sitting there and staring at the screen, consistently waiting that when will this torture be over. Climatology will be a significant burden for you. But on the other hand, if you are trying to associate with your day-to-day experiences, that is something which is going to be beneficial, and that is something which will keep you up as well. So let's take a break for 15 minutes. Let's be back at around 9. Okay. A confirmation regarding the audio, please, guys. If you're able to hear me out, kindly confirm. Thank you. So now we come to the various different modes in which we experience the heat to be received in the atmosphere and also to the heat to be distributed in the atmosphere. So first of all, what is the source of heat for the atmosphere or the earth's surface? The earth's surface does not receive heat from the interior. It is not as if just because the core is so heated up, that is why the earth's surface will also get heated up. No. The earth's surface receives its heat primarily from where? From the solar energy. And that energy is received upon the surface by the method of radiation. Now, this radiative energy that we receive from the sun, you can also have that kind of an argument that a radiative energy which is received from the sun, it will heat the atmosphere, then it will heat the surface. Or will it be a situation where it will first of all heat the surface and that surface will then in turn heat the atmosphere? So let us analyze that. So basically, here, let us consider this to be the surface. Let us consider this to be the atmosphere. And let's suppose the solar heat is coming in. Now, first of all, that heat is going to have its impact on the surface. The surface is going to get heated up. And that surface, when it gets heated up, that is when the heat is transferred into the atmosphere. Why is this the case? So, in order to imagine that, or in order to understand that perfectly well, again, take the case of, let's say, if ever you have had a blowtorch or a kind of a matchstick or any cooking stove. Now, there, if let's say there is a flame, right? Let's take a simple candle. If nothing else, candle is something with which you would have had multiple experiments in your life. So let's suppose this is a candle. Now here, if you try to feel the temperature of air here by moving your hand, it will be slightly warmer, but it won't be scorchingly warm that it will boil off your skin. But then put your hand there for a long period of time, for a prolonged period of time. Your hand will burn off. Your hand simply will start burning. Why? Because it is a solid. Gases, they have a significantly lower amount of heat reception capacity because the molecules, they can move very easily, they can get displaced very easily. So the gases, they don't get heated up to that great extent by the incoming solar rays. I'm not saying that there is no impact, there is some impact, but the gases, they are not significantly heated by the incoming solar rays. On the other hand, when those incoming solar rays, they fall on the solid surface of the earth, that will heat up the surface. And that heating up of the surface, in turn, will start heating the atmosphere. How? First of all, by the process of conduction. What is conduction? Conduction is the method of transfer of heat when two bodies of unequal temperature, they get in contact with each other. So here, this is a method of transfer of heat. Transfer of heat by being or by the virtue of two bodies being in contact. Contact with each other. So, the gaseous molecules which will come in contact with the ground surface, the lowermost layers. Now, those gaseous molecules, Because they are in contact with a very hot ground surface, they will also start gaining some heat, isn't it? They will also start getting heated up. Anything which gets heated up eventually has got the property to rise. We have seen in the case of convection currents and the convection current theory earlier as well, that anything which is significantly heated up, especially in the case of liquid medium, you would have observed that bubbles, they start rising from the bottom of the utensil and eventually they move their way up. So once you have the air which is heated up near the ground surface, there will be convection. So that convection will lead to the air being able to climb up. Now, this warm air, let's suppose it reaches here. So, what will happen? It will transmit the heat all around, isn't it? There is a vacancy created in the lower portion. So, the colder air from top, just like a convection current in play, the colder air will replace it. So, convection is a method by which the heat is transferred in the atmosphere. But the heat which is given in the atmosphere is primarily because of the contact that it has from the ground surface. Okay? So here we can say convection is responsible for transfer of heat in atmosphere. Okay? It is responsible for the transfer of heat in the atmosphere. So, in a way, we can say that conduction, convection, and radiation, all of them primarily are responsible for heating up of the atmosphere. What is radiation? We have seen earlier that when we talk about radiation, the incoming solar radiation, the terrestrial radiation, that is the energy which travels, the heat energy which travels in the form of wave-like format, that is what we refer to as the radiative energy. So that radiative energy, first of all, heats up the ground surface. So sun heats up the ground. That is the first step. The second step of the way, this is the first step. The second step will be that the ground will heat up the air immediately above it by how? By being in contact. If you consider this, here you will observe that this represents the air which is in contact. Right? I hope that you are able to see this. This represents the air which is in contact. So the air in contact gets heated up because of conduction. And what is convection? Convection, we know in the case of the earlier convective currents, we had already seen that if you put a utensil on fire or if you heat it up, and there is liquid water which is present. So initially the bubbles will be formed closer to the surface, it will rise up and the colder water replaces this. This is a convection current we have seen. That is what drives all the plate tectonic movements all across the surface. So a similar convection current is at play in the atmosphere as well, where if you consider this to be the surface and this to be the atmosphere, then you will have the warmer air rising up, moving, and then the colder air sinking below. So this is your convection current. Now I understand all these basically is something that you would have covered in your um, school days, in your class 8th, 7th syllabus. This is something which is present. Now it depends how much attention you have paid at that point of time. But nonetheless, even if you have not paid any attention at that point of time, still I hope that this is something which is easily understandable. But then this heat transfer, it is not something which happens only because of conduction, convection, and radiation. Sometimes you would have experienced during the summer conditions, or even during present day and time, even during the present period. Many areas of the country you are receiving rainfall, right? So you would have experienced in general in your life that maybe the conditions are very, very hot. The conditions are very, very hot, and the air is also very warm, but suddenly it becomes pleasant because there is cold air coming from somewhere, and the temperature becomes much more tolerable, the conditions become much more tolerable, and you are able to experience a cooler condition. Similarly, in the winter times, you would have experienced that it might be shivering cold, but suddenly there is a kind of a relief which is provided because there is warm air coming from somewhere. So that is again what we refer to as transfer of heat or distribution of heat. So distribution and transfer of heat can also happen due to horizontal movement of air. Air moving from a warmer area to a colder area, it will bring warm air. Air moving from colder area to warmer area, it will bring cold air. So in the case of convection, what do we observe? Here we observe vertical motion of air or heat distribution through vertical movement of air. Heat distribution due to vertical movement. Right? But then there is a significant heat distribution which also occurs due to horizontal movement of air. And that horizontal movement of air that we experience in the form of wind, breeze, all that, that is referred to as advection. So advection is basically the transfer of heat through horizontal movement of air. Now, it can be of two types. It can be a condition where colder air is coming to a warmer region and cooling that region. It can also be that warmer air is coming to a colder region and thereby also influencing the temperature. So that temperature change which is brought about by horizontal movement of air, that is advection. Now, horizontal movement of air is relatively more important than vertical movement when it comes to temperature distribution in the atmosphere. For temperature distribution in atmosphere. Okay, so horizontal movement of air, that is something which is relatively much more significant and much more important for temperature distribution. Now, this advection is of broadly two categories. One is what we refer to as cold advection, and then what we refer to as warm advection. What is cold advection? Colder air coming to warmer areas. Why it comes, when it comes, leave that out. We will cover in the following modules. So cold air coming to warmer areas. So when the cold air comes to warmer area, it will significantly raise the temperature, isn't it? Or colder air coming to warmer area, it will cool down the temperature. So it provides a cooling effect. Cooling effect. Warm advection is when you have warm air moving to colder areas. And there we have a warming effect. So This is again a mode of heat transfer. So basically, cold advection is a process in which wind blows from a region of cold air to a region of warmer air, which results in cooling of the warmer region, whereas warm advection is the process in which the wind blows from a region of warm air to the cooler air, thereby warming a region. So that is how you have the cold advection and warm advection. This is experienced in different parts of the planet to varying degree, thereby leading to temperature changes in various parts of the planet. Now then, we come to the concept of lapse rate. But before coming to the concept of lapse rate, I will take you back to this particular portion. And based upon these factors, that how heat is received and how heat is distributed into the atmosphere, I will give you two different places. So let's have a place A and let's have a place B in the atmosphere. Let's say B is 5 kilometers above the surface, or let's say it is at an elevation of 10 kilometers above the sea level. Let's say, okay, and A is at the ground level. Now we know that first of all, heat is received by radiation, then it is conduction which provides heat, and then that heat is transferred by the vertical movement of air, that is convection. Now, if I were to ask you a question, and for this again, I will have a poll, that out of A and B, where is it that the temperature will be higher? Which of these will be warmer? What do you think? Out of A and B, which is going to be warmer? Very good. It will be A, isn't it? This will be significantly warmer. It is, after all, this warm air which will rise up and heat up the other regions. But by that point of time, its temperature will already reduce as it is consumed in warming up the air around it. Its own temperature will be lost slightly. So that is why you will always find the condition where A is warmer and B is colder. Right? So as we move higher up in the atmosphere, at least in the lower regions of atmosphere, as we end up moving away from the surface, the temperature starts to drop. That is why if ever you travel by an airplane, and when the airplane reaches its cruising altitude and the pilot announces the outside temperature, if ever you have listened to what the pilot announces as the outside temperature, you would be significantly shocked. So the temperature outside generally in the aircraft when it is flying, that is somewhere around -40, -44 degrees Celsius. That means higher up, the temperature is very low. So that is what happens generally as you move higher up. So that is what is referred, the rate of change of temperature with the increase in height, that is what is referred to as lapse rate. So it is the rate of change of temperature as one moves higher up in the atmosphere. Rate of change, okay, how it is changing. So the change can happen in different ways. Because of different conditions, the change can happen in different ways. It can also happen that temperature, as is the case, temperature decreases with height. Decreases with height. Temperature in certain conditions and in certain regions, temperature increases with height. Right? And you can also have temperature remains constant or doesn't change with height. So all these, they form different types of lapse rates. So this is what is referred to as a positive lapse rate. Positive lapse rate. This is what is referred to as a negative lapse rate. And then when it does not change at all, that is what is referred to as a zero lapse rate. So that is how you have the change in temperature that is referred to as lapse rate. Now here, when we talk about the aspect of the lower portion being the hottest one, why is it so? Why is it so that the lower portion of the atmosphere is the hottest one? So that is because of two reasons. So the lowest or lowest layer being the hottest. So what is it? First is the source of heat is the surface. The surface is the one which is giving out that heat. So as you move away from the source, the heat reduces. So as you are moving higher up, you are moving away from the source, so the temperature will reduce. Also, the density of atmosphere will be highest where? Closest to the Earth's surface. Why? Because of gravitational pull of attraction, density of air particles will be maximum closest to the surface. So, as the density is greatest, as the density is highest, the air or the particles trap more heat. Okay, the air is able to trap greater amount of heat or more heat in general. Now, we say that the temperature decreases with height, increases with height, all of the things can be possible. And as we move ahead, we'll take a look at the instances when this happen as well. But in general conditions, the layer of atmosphere that is present closest to the Earth's surface, that is the troposphere, there we will experience the temperature decreases with height or a positive lapse rate is experienced. In general, as you move higher up from the ground surface, in general, as you move higher up from the ground surface, you move higher up from the ground surface, you will experience that the temperature reduces at a rate of around 6.5 degrees Celsius per change in kilometer. So in general, the rate of temperature change or temperature decrease is at the rate of 6.5 degrees Celsius per kilometer. This is what happens naturally, normally on an average. This is the average condition which is taken. So that is why this is also what is referred to as an environmental lapse rate. Environmental lapse rate, or what we refer to as ELR. It represents average conditions. But then this represents the average conditions. But then we have seen that water vapor has got the propensity, or rather the ability, to be able to trap heat. We have seen that. That is why we have discussed that when there is humidity, it will heat up. There is more warmness which is present, isn't it? Now I give you two different cases. In one case, for example, let's suppose there is lot of water vapor, huge amount of water vapor which is present in the air immediately. Let's assume, right? And this, let us name this place A, and here B, which is dry. This is moist. Now, if the ground surface temperature is the same in both these cases, now the air temperature will be higher in which of them, A or B? What do you think? Air in A or B? Again, I will launch a poll. Don't worry. I'll launch a poll. So, if the ground surface temperature is the same in both the cases, which is going to indicate greater amount of heat which is present? Air in A or air in B? What do you think? A is moist, has got a lot of water vapor which is present. Let me know. Why sun doesn't directly heat the atmosphere? Because already I have said that these are gases. It is easier to heat solids, and gases, because they move, so heat is not trapped in one place. Okay, this is surprising. Yes, Anil, you are correct. Pranay, you are also correct. Okay, so I guess many of you are getting confused with the aspect that water vapor should ideally provide cooling. How many of you have this opinion that because there is water vapor, it should naturally provide cooling, because water is something which is cool, so water vapor should also be providing some amount of cooling? How many of you have that kind of an opinion? Okay. Water vapor does not provide any cooling. Water vapor, on the other hand, provides heating. Why? So, all those of you who have either missed the earlier portion of the session or have basically snoozed through the earlier portion of the session, please notice this part. Water vapor traps the terrestrial radiation and is able to maintain heat. Water vapor traps heat. It does not provide cooling, it traps heat always. That is why when you go to a region which is having lot of humidity, you will find find the conditions very intolerable, and in a way significantly atrocious, to say the least. For example, if you go to the region of let's say the coastal areas, right? I will not take the name of the city because many people get very touchy immediately when you take the name of the city. But if you take the example, let's say, of Mumbai, right? Now, in the case of Mumbai, if you go to the coastline and the coastal area, it is not a pleasant weather. You will start sweating and you will feel the heatness or the hot temperature at the same time. Whereas when you go to Delhi, the temperature might be greater slightly, but you will still feel comfortable because the water vapor is not there. Water vapor traps heat. Always understand that water vapor droplets which are present, they will be trapping heat. They never provide cooling activity, right? Any instance that you can tell me where water vapor provides cooling to any place, any instance that you can recount? You will not be able to recount any instance or any incidence where water vapor has cooled down a surface. Even if you have to cool down yourself, you don't take the help of water vapor. What do? You take the help of liquid water droplets. So water vapor is different. In Delhi, it is not as if there is no water vapor is less. Okay. So vapor always will trap heat. Always remember that. So that is why moist regions, they are always going to be warmer as compared to the drier areas in terms of how much heat is trapped. So this atmosphere, when it is moist, it will be trapping and retaining heat. And if the air is dry, it will be losing heat very quickly, because that heat in the atmosphere, what is the source of that heat in the atmosphere? What do you think is the source of heat in the atmosphere? Okay, Pratyaksh, you are correct. Abhishek, you are correct. Deepika, you are correct. All of those who have still said that sun is the main source of heat, please understand, sun is not the main source of heat for the atmosphere. Sun heats the ground surface. That is what our entire discussion for the past hour has been. That sun is the one which is going to heat the ground surface, and then that ground surface is going to heat up the air above. Okay, so all of you, please, again, I hope that now you have woken up significantly well. Maybe in the first half you did not have breakfast or whatever might be the case, but now open up your ears and your logic and your mind. Sun is never the prime source of heat for the lower regions of atmosphere. And I will repeat it for the 20th, 30th time. Sun heats the ground surface, and that ground surface releases heat, and that is the one which will heat the air above by the method of conduction and convection. Okay, always keep that in mind. So the heating of the atmosphere that you see, that is in the form of the outgoing terrestrial radiation. That is what heats up the atmosphere above. Now, if you have to consider that where is it that the air will be able to retain greater heat, you will always find that in the moist regions, there is a greater retention of heat. Write it somewhere. Write it on a wall if you want to. Note it down somewhere. Greater retention of heat will always be there when the conditions are moist, because water vapor will trap heat. I hope this is clear now. Anybody having the doubt here? Okay, Amritansh, here does water vapor is different from water we used to use in our older coolers during. Okay, so how many of us we understand what is water vapor? Water vapor is the gaseous form of water. You have the water that you drink, the water that you put in your air coolers, that is the liquid form. Water exists in three forms: solid, ice, liquid, the water that you drink, and vapor. Water vapor is not something that you put it out or you can touch it out. It is a gas. Water vapor is not something that you will be able to feel, you will be able to touch, or you will be able to feel. No, what you are feeling as some water droplets coming on your face if you are sitting in front of a cooler, that is basically liquid water droplets which are coming. Please understand, water vapor does not mean small liquid droplets. When you have droplets, that is the liquid state. Okay, right? Please repeat the last sentence. The last sentence was that water vapor is not a liquid, it is a gas. Okay, guys, the state of matter, that is solid, liquid, and gas, if we have confusion in this, then it is a very hard task going ahead to the complex phenomena like jet streams. And when we talk about polar front jet stream, I'm sure when we come there, all of you will have the most complicated of doubts, because you would have heard that, okay, in United States, Derecho happened. So please tell us what Derecho is. I don't know what liquid water and gaseous water is, but explain to me what Derecho is. So please simplify it a bit. I hope that this liquid and solid and gaseous form, I hope that we don't have to spend so much time in it. All of you, and this is a humble suggestion, take it constructively. all of you, if you have significant amount of doubt in this basic science, there is no harm in picking up the science books from class 6, 6 to 8 science books, NCRT, any science book, 6 to 8 standard. Go through it. And there the logic doesn't work that I'm not from a science background, etc. That logic comes into play for higher level. The 6 to 8 science book you should study, so that you have some idea what do we mean by vaporization, what do we mean when we say latent heat, what is condensation. That kind of confusion, if it persists, cloud formation, etc., is a very, very distant dream. So please get it clear. All of you who have the doubts in that, you will have the day of today, you will have tomorrow. So do revise those portions of science, because when we move ahead into the portions of climatology, we will be moving with the assumption that at least 6th, 7th level of science is something which is clear. Then we will be moving ahead. Okay. So all of you who have no, geography is a different matter, Swaroop. For this basic aspect, that is difference between vapor and liquid water, study science first. 6 to 8 level science you study, get an idea about what liquid water looks like, what vapor looks like, what is evaporation, what is condensation, when condensation will happen, what is latent heat, all of that. Get an idea about it. It will help you. And here nobody should have feel it on their ego that now he's saying I'm there to clear UPSC and he's telling me to read science. I have seen many candidates who did not, for various reasons, for economic reasons, financial reasons, they did not get the opportunity to have their schooling in a particular way. So they took it back and they started studying with the initial portions, and they have managed to attain very good rank. But for that, you need to work hard. Some part of it, you need to work hard as well. It might seem harsh, but it is a necessary advice for your betterment. Okay, so please take that into mind. So again, I would reiterate that when we talk about moisture, vapor retains heat. Vapor always retains greater amount of heat. When you have dry air, the heat is lost very quickly. When you have moist air, the heat is retained. That is why I said that cloudy nights are warmer than clear nights. When the sky is clear, the conditions are cooler as compared to the cloudy nights. Why? Because the terrestrial radiation is reflected back by the clouds and the vapor which is present. So that gives the concept of dry and wet lapse rate. Wet lapse rate and dry lapse rate. So wet lapse rate is the rate of temperature change or temperature drop when there is lot of moisture. Dry lapse rate is the rate of change of temperature when the air is very dry, when there is almost negligible amount of moisture, like you find in northern part of India, or for example in the region of Rajasthan, in the region of Haryana. There you will find the air is particularly drier, right? So in the case of wet lapse rate, because vapor retains heat, the rate at which temperature falls with the increase in height, that is around 5 degrees Celsius per kilometer. In the normal conditions, average conditions that we observed, it was 6.5 degrees Celsius of change per kilometer. In the case of wet lapse rate, you will observe that because there is lot of vapor and vapor retains heat, that is why the rate of change is around 5 degrees C per change in kilometer. And dry lapse rate, there is no moisture, so vapor retains heat. In that case, there is no vapor, so there will be no retention of heat. So it will be at a rate of around 10 degrees Celsius per kilometer. On an average, we assume it is 6.5 degrees Celsius per change in kilometer. Okay, so that is where you have the varying degrees by which the temperature changes as we move up in height. Is there a doubt which prevails? Any doubt? Having said that, by moving higher altitudes, temperature decreases, then how come water will remain in the state of vapor? But then that is where you have very small liquid droplets which get converted. When you have, that is why majority of the vapor, Sachin, that you will observe will be at a height of less than around 5 kilometers only. Beyond that, it starts getting converted. Yes, Deepika, that is correct. Sweetie, how is it higher lapse rate of dry? Lapse rate is what? The rate at which the temperature falls. Okay? So the rate at which the temperature falls as you move up into the atmosphere. So again, I will take this instance. For example, this is the ground surface. Now again, I will repeat, vapor retains heat. Vapor, water vapor, which is gaseous form of water, that retains heat. So then, if you consider, for example, an area A and an area B, let's suppose in an area A, you have lot of vapor which is present, and vapor is able to retain heat, right? If suppose I consider a height of 2 kilometers, and here also I consider a height of 2 kilometers. Now here, if the ground temperature is 40 degrees Celsius in both the cases, vapor retains heat. So chances are that this place will be warmer in general. Why? Because vapor retains heat. I will repeat it so many times today that even during night when you try to sleep, you will get the nightmares of someone screaming in your head that vapor retains heat. So that is the main purpose here. I will keep on repeating it because this is something that you should be knowing. Again, vapor retains heat. So basically, vapor is the one which will retain heat. So there, the loss of heat through terrestrial radiation won't be very high. Why? Because vapor retains heat. Now here, this will be warmer, this will be colder. Why will it be colder? Because you don't have the presence of water vapor. So all the terrestrial radiation will be lost very easily. So if this is warmer, this is colder, can I not say that the rate at which the temperature is dropping is more significant in B as compared to A? Can I not say that rate of temperature drop is higher? We can say that rate of temperature drop is higher. So what does that mean? That is lapse rate. So lapse rate is always going to be higher in drier conditions as compared to moist conditions. Why? Because vapor retains heat. Okay, I hope that is clear. Now, that is the reason when you talk about regions such as, let's say, if I consider Rajasthan, and on the other hand, I consider, let's say, Chennai, very humid, very that is why in Chennai you will find the conditions to be very atrocious sometimes. Same is the case with Kolkata. There you will have very high amount of water vapor, and vapor retains heat. So that is why you feel greater amount of temperature there. Now, if I consider Rajasthan and if I consider, let's say, Kolkata, now in this situation, here, If the ground surface temperature is 40 degrees Celsius, in this situation also the ground surface temperature is 40 degrees Celsius. If I rise up by 4 kilometers in both the cases, what will be the temperature? In Kolkata, we have high humidity. Humidity means vapor, and vapor retains heat. So here you have high moisture. So in the case of Rajasthan, this is dry. So wet lapse rate will come into play here. Wet lapse rate is 5 degrees Celsius change per kilometer. So if it is 40 degrees Celsius here, what will be the temperature 4 kilometers above? It will be 20 degrees Celsius. Whereas what will be temperature of Rajasthan 4 kilometer higher? The dry lapse rate is 10 degrees Celsius per kilometer. So 4 kilometers, it will be 0 degrees Celsius. That is how, despite the same temperature being present on the ground surface, you can have different conditions of temperature in the atmosphere based upon the moisture which is present. Okay? Uh, Amit, average rate is considered because of absence of water vapor. No, average rate is never considered in the complete absence of water vapor. No. Complete absence of water vapor means the loss of heat will be very cool and at a very fast rate. Okay. And Shruti, with temperatures in wet and dry lapse rate, because wet lapse rate, but it is more hottest. I still confuse with temperatures in wet and dry lapse rate, because wet lapse rate is only 5-degree changes, but it is more. See, your question is not clear, guys. So again, I would request you, I would urge you with folded hands, when you put out your question, try to have a kind of thing which is clear. It might be clear in your mind, but someone who is reading it, it is not clear. Anil, why is it that it should be 0 above Kolkata? Please let me know. Here you have wet lapse rate. Temperature retention over ocean is very high, Sarthak, because there will be lot of moisture and vapor retains heat. Okay. In weather app alone, there is another, right. So, okay. So environmental lapse rate is the rate at which the temperatures change with an increase or decrease of altitude. So it is the vertical distribution of temperature as you move higher up into the atmosphere, how the temperature is changing. That is what is referred to as environmental lapse rate. So if the lapse rate is positive, the temperature decreases with height, which is usually the case. And if the lapse rate is negative, the temperature increases with height, which we refer to as a temperature inversion, which we will study later. Okay. Yes. No. See, Yaram Seti, see, that is the entire other aspect of evaporation. When in summer conditions, when it is very dry and you start sweating, why do you sweat first of all? Have you ever wondered why is it that your body starts sweating? That is your body's way to maintain your temperature. So when you start sweating, that sweat will evaporate. And when it evaporates, it provides a cooling effect, right? So the evaporation will cool you down, but the water vapor will be present in the region around. Why Bangalore is so cold, but there is no sea floor? Sea floor? Where does this aspect of sea floor come into the picture for cooling? Ladakh is also very cold, but there is no sea there. Jammu Kashmir is also very cold, there is no sea floor there. So why that case of Bangalore you are asking? Okay, Shruti, now your question has come, a detailed question. Because wet lapse rate is only 5 degrees per kilometer changes, but it is more hottest than dry lapse rate. Okay. When we say lapse rate, does lapse rate indicate an absolute temperature? No. Lapse rate is the rate of change of temperature. It is the rate at which the temperature will change. Okay. The rate at which the temperature ends up indicating a change. Now, rate of what? And temperature change between where to where? If I'm standing here, will I be able to experience lapse rate here? That, okay, I'm standing in a moist region, so the lapse rate is different, so I will get less heat or experience more heat? No. So the heat that you feel, that does not constitute lapse rate at all. Lapse rate is as you move higher up into the atmosphere, what is the temperature which is present? We already know that at higher up, the temperature is lower as compared to the ground surface. Isn't it? We already know that temperature is lower as compared to the ground surface. But how it is lower, why it is lower, at what rate does it lower down, that is where the concept of lapse rate comes in. If there is high humidity, you feel warm or you feel cold, that has got nothing to do with lapse rate. So when I say vapor retains heat, that was to tell you the aspect that when there is lot of moisture, lot of heat will be retained there. That is why if you consider the atmosphere, okay, let me try something else here. Let me try something else. So first of all, let us be very clear, what do we mean by lapse rate? Lapse rate is change of temperature, or rather, to make it more clear, rate of change of temperature. And in the meanwhile, with folded hands, I urge all of you, please don't feel bad about it. Open up class 6th NCRT of science, study what is there. You might have all the confidence in the world, you might know all the knowledge in the world. There is no harm in doing that. Open up class 6th level book NCRTs, study that. Class 7th NCRT, study that science. Okay, this basic, do it. It will be clear significantly. Rate of change of temperature. Rate at which the temperature is changing. So if I give you two conditions, condition A and condition B, where condition A has got moist air, condition B has got dry air. If the ground surface temperature in both the cases is 40 degrees Celsius, here moist air means there will be a lot of moisture. Moisture means what? When we say moisture, it is water vapor. Water vapor is what? Gaseous form of water. So you will have lot of that water vapor which will be present. What is lapse rate? Rate of change of temperature. So here, if I consider this particular height, this particular altitude, now, where is it that it will be warmer? Slightly in comparison. Will it be warmer here or here? Always where there is moisture, there will be slightly warmer. So it will be, let's suppose if I consider the temperature at this particular height in this case to be around, let's say, 32 degrees Celsius, let's assume, here always you will find that the temperature is invariably somewhere around 35 or 36 degrees Celsius. Okay, so here the rate of change is lower in the case of moist air. Why? Because moist air will be comparatively warmer. If it is more warm, or if there is more significant amount of vapor which is present, if more significant amount of vapor is present, if I then measure the temperature here and here, let's assume the temperature at this point of time is 25 degrees Celsius. The temperature in this point will be invariably somewhere around 32, 33 because it will retain more heat. So temperature will be around 32 degrees Celsius, let's assume. Now, in both these cases, the temperature is decreasing, but the rate at which the decrease is happening is variable. So, if the air is dry, the rate of decrease is more significant. So, when the air is dry, temperature is lost more rapidly. And when we say temperature is lost means what? It becomes colder more rapidly, and hence lower temperature. Hence lower temperature. In this situation, if I consider, temperature is lost gradually or very slowly. Why? Because there is presence of moisture, and moisture retains heat. Moisture retains heat. Okay? So that is, in both the cases, the temperature is decreasing in both of these situations, but the rate of decrease is different. So the rate of decrease will be more drastic in the dry air and will be less drastic in the moist air. Why? Because moist air will have vapor and vapor retains heat. Always consider that. Okay? I understand, Arshia, that it is very inconvenient for rest of you, and I hope that somehow you are able to manage this, because even I did not expect to spend so much time on this simple concept, because all of you getting your mind entangled in this concept, you don't know what lies ahead for climatology. So climatology is, this is a kind of a very basic aspect, and it is something we cannot even say is of the 10th or 11th 12th level. This is the increase and decrease of temperature, guys. If you still have confusion, kindly look at the entire thing, read it up with your eyes wide open, and you will understand it. It is not a concept out of this world. There are concepts out of this world which will come in your way. This is one of the simplest concepts, that how the temperature is decreasing as you move up, that is determined by what is present in the air, isn't it? Won't that determine how the temperature is decreasing or increasing? That is the entire concept of dry lapse rate and wet lapse rate. If you still find it confusing, ignore that. Just understand what is lapse rate, what is positive lapse rate, what is environmental lapse rate. Just stick with those. For general studies, close all the mind. Other than that, even that will be sufficient. Okay, again, I will repeat, for general studies, if you still find it confusing, ignore this. Just look at, or just simply learn it off. Environmental lapse rate is 6.5 degrees Celsius per kilometer. Okay. Now, Now we move ahead and now we come to the portion of adiabatic process. Adiabatic process is again another methodology of heating and cooling of the air. So it is another methodology of another method of heating and cooling of air. So when we talk about, yes, Shiva, you are correct in this. So when we talk about the air being able to transfer heat, till now we have seen that the air transfers heat based upon the heat received on the surface, and then it is able to transfer heat. So the air directly in contact with the ground surface will get slightly heated. It will transfer heat above to the region above, over it, and so on, right? So that is when you have a source which provides heat to the upper region. Now, in the case of adiabatic process, when we talk about adiabatic process is basically when you have the heat gained or lost by the air parcel without any external source of heat. So here the heat is gained or lost by the air parcel just by the change in volume. Okay. So let's do one thing, guys. Let's take a 5 minutes break and let's come back and we will continue. Okay, let's take a 5 to 7 minutes break. Let us all recalibrate ourselves after that lapse rate. So we'll take a break of, we'll meet at 10:10. Yes, Anirudh, we are going extraordinarily slow. Pranay till 11. A confirmation regarding the audio, please. Thank you. Now, we come to the adiabatic process. Adiabatic process is the case where the air heats up or cools down by the source of or by the virtue of change in its volume itself. It is not the air warming up or cooling down because there is a heat provided from the ground surface or cold conditions provided from the ground surface. That is the crux of adiabatic process. So for example, if you observe the simple experiment where you compress the air. So, in that process, when you compress the air, what will happen? You will come across a scenario where the air molecules, they will undergo more collisions, significantly more amount of collisions. Let's suppose I take parcels of air. Now, this will have many gaseous molecules which are present. Now, if this is compressed significantly, if I allow it to compress significantly and I constrict the space till here, what will happen? The molecules are forced into a lower volume. So when the molecules are compressed in a lower volume, there will be more molecular collisions which will happen. More collisions will happen, leading to what? When the molecules, they will collide, they will produce heat. So more molecular collisions will lead to what? A greater amount of heat. So always when there is compression of air, that will lead to heat. So compression leads to heating. Now in this case, the heating which is present or provided, that is not provided because the ground is heated up significantly or because of wind movement, etc. It is just by the virtue of change in volume. If you take another case where this air is allowed to expand. Now, when the air is allowed to expand, that means what? The molecules will occupy larger spaces. They will all have larger space amongst themselves. Now, here, what will happen to the rate of collisions? It will reduce. So, there will be lesser heat which will be produced. So, that is where expansion will always lead to cooling. Expansion will lead to cooling. Here again, the cooling is provided by the change in volume of the air. So, when an air parcel rises up, will it expand or will it compress? What do you think will happen? When the air parcel starts to rise up, will it expand or will it compress? Very easy. It will expand. So that is why a rising air parcel will always undergo a kind of an expansion. Rising air parcel will always bring about a kind of an expansion. So that is why whenever an air parcel rises up, it will start to cool down. It will give its heat to the surrounding areas, it will expand, it will cool down. On the other hand, if you have air parcel which is present at a height of 5 kilometer, let's suppose it is forced due to the air movement on the ground surface. I will repeat. If there is an air parcel at a height of 5 kilometer and it is forced to come to the ground surface where already the density of air is at its maximum, then it will be forced to compress. So that is why sinking air parcel, where it naturally sinks down, that will always get heated up. So that is why you will find that sinking air will always end up getting heated. So this heating and cooling of air without any external source of heat, but purely by virtue of change in volume, that is referred to as adiabatic heating and adiabatic cooling. So when we say adiabatic cooling, so that is the condition when air is forced to rise up in the atmosphere, the air density and pressure reduces with height. So in that case, as the parcel of air will expand, so there its temperature will fall due to lower and fewer molecular collisions and in the larger volume. So always that is why the expanding air will experience lower temperature. So that is why we experience a decrease in temperature. Conversely, when you have an air which is forced to compress, an air parcel which is forced to compress, that is when there will be greater molecular collisions and there will be greater production of heat as well. So adiabatic heating results when you have a cooler air that is something which experiences an increase in temperature due to compression or an increase or decrease in volume. So here the molecules are forced to a region of higher air density. Due to this, molecules become agitated, they start vibrating and indicate an increase in heat. So that is what we have as the case of adiabatic heating and cooling in general. Naturally, if you think about it from a normal example, if this is the air, let's suppose this is an air parcel which is warm. Now, as it rises up, it is going to an area where the density of air is less. Density of air is maximum closest to the surface. Why? Because of the gravitational pull of attraction of the earth. So as it rises up, it enters into a region where the density of air is less. So as it enters into the region where density is less, it will naturally tend to expand a bit. So when it expands, what happens? There is cooling. That is adiabatic cooling. On the other hand, imagine that there is a mountain and air is moving in a region like this. So when the air is climbing up the mountain, it is going to expand easily. But then after that, once the air starts getting pushed down, then what is happening? The air is being pushed into a region where the volume is reducing. The volume is being forced down. So here in this portion, the air experiences compression. Experiences compression. And when the air experiences compression, that leads to what? That leads to heating or warming of the air. And that is adiabatic heating. So we will come to the process of adiabatic heating and its utility when we talk about winds, the permanent winds, local winds. There will get a use of this. But this is the basic concept of it. Now we come to the portion of atmospheric structure. This is where we study the various different layers which constitute the atmosphere. Now, when we talk about the layers which constitute the atmosphere is constituted of various different layers. It is not homogeneous at all. So, closest to the ground surface, you will have the maximum density of air. As you move higher up, the density of air tends to reduce significantly. So, that is where as the density reduces, there is change in temperature, there is change in pressure conditions, and so on. So overall, if you take a look at the structure of the atmosphere, it can broadly be divided into various different layers. So the layer which is present closest to the ground surface, that is what is referred to as troposphere. Troposphere is the layer of air closest to the ground surface. Above it, you have the stratosphere. Then comes mesosphere, and beyond that, the air is distributed unevenly. You might have molecules in place, but the molecules might be absolutely very far away from each other. So the air is still going to have the presence of the gases that we see in a kind of a considerable proportion up till the height of the top of mesosphere. Beyond that, you won't experience the same phenomena or the same event. So one by one, let us take a look at the various different layers of atmosphere and let us try to understand their associated properties. So the layer closest to the Earth's surface or the lowest layer of the atmosphere, that is what is referred to as the troposphere. Now, troposphere consists 80% of the mass of the atmosphere. Okay. In the case of troposphere, you will observe, now I'm afraid to take the name of the term and it will give me shivers, but still, if I ask you that what kind of lapse rate will you observe here, let me directly tell you that here you will observe a kind of a positive lapse rate. Positive lapse rate. That is where in troposphere temperature reduces with an increase in height. And we have talked about it in significant detail, I guess, in more detail than you will find in any other book or any other material or any other source. We have talked about it in greater detail. So temperature reduces with an increase in height. So in troposphere, we experience what is positive lapse rate. Now, the average height of troposphere, it is not fixed. It is something which keeps on changing. And moreover, in different parts of the planet, you have the different height which is exhibited by the troposphere. So you will observe that even though the average height of troposphere is taken around 12 to 15 kilometers, then in the case when we talk about the region around equator, the height is around 18 kilometers. The height of the troposphere around equator is around 18 kilometers, and the height around the poles is somewhere around 8 to 10 kilometers. So here, if you observe this image, observe that around the region of equator, the height is significant, whereas around the region of the poles, the height is less. Now, why does that happen? That happens, and why this variable height is experienced, it happens because of very simple conditions and very simple reason about the movement of air. So let's consider this to be the Earth's surface, right? Let's consider this. Now, let's assume this is the equator. This is the poles, 90-degree. Now, in general, the region around equator will receive greater amount of heat. That will be heated significantly. Anything which is heated tends to slightly expand, ever so slightly. Anything which is heated, any state of matter, any material, even if I heat this pen, if I heat this watch, if I heat my spectacles, anything that you heat, it will start to expand. In the region of equator, there is greater heat which is received. So here, greater heat. Now, greater heat which is received means what? There is a general expansion. And in the region of the poles, the temperature is very, very low. So there is a kind of a natural contraction which is observed, a natural reduction in volume which is observed. So here you will observe a contraction or reduction in volume due to low temperature. So because of these factors, there is a slight change in volume which occurs. But to add on to the fact that when we talk about the equatorial areas, the areas closer to the equator which receive very high amount of heat, there you will experience that as the air warms up, the air tends to rise significantly as well. So here you will have rising air column, due to greater heat. And why do we have a rising air column? It is a part of the convection current that we have seen or that we have talked about. So as this rising air column comes into existence, it will provide a greater extension of the troposphere. So this rising air column, it is greater in the region of the equator. Whereas in the region of the poles, you have very low temperature. So naturally, the air will try to sink down. Naturally, the air will try to fall down. So that is why this rising air column further pushes the height of troposphere around equator. Further pushes the height of troposphere around equator. Okay. So that is why, because of these reasons, that is the general expansion of air and the presence of the convective currents in the region of equator, because of these two reasons, you have a greater height of troposphere around the region of equator as compared to the region of the poles. Okay. Now, troposphere is marked by a presence of a very thin discontinuity of sorts. That is what we refer to as tropopause, and that creates or that marks the difference between troposphere and stratosphere. So this demarcates the difference between troposphere and the layer immediately above it, that is stratosphere. Okay, that ends up demarcating the difference. Now, when we talk about stratosphere is where you will experience that the temperature suddenly rises up. The temperature gets very high, not very, very high, but it will fall back to around 0 degrees Celsius, because by the time that you reach the top of troposphere, the temperature at this point can be around -80, -85, -70 degrees Celsius as well. So, because in the region of troposphere, you have a positive lapse rate, so the temperature will drop. In the region of stratosphere, there is heating which is present. And why is that? Because in the region of stratosphere, when we talk about it, in the region of stratosphere, we have the presence of a very thick layer which we refer to as the ozone layer or the ozonosphere, that we study in environment and ecology as well. So here you have the presence of very thick ozone layer. Now, this ozone layer, what it does is, this ozone layer traps and filters out the ultraviolet rays given and emitted by the sun. So when the solar radiation comes into play, basically, significant portions of ultraviolet rays, they are trapped and they are reflected back. These are UV rays or ultraviolet rays. Now, because the ozone layer is absorbing so much amount of ultraviolet rays, not only absorbing but releasing it back as well, that is why you will observe that this provides a kind of heating. heating is provided. And this heat which is provided, that will heat up the entire stratosphere in itself. That is why when you go into the region of stratosphere, it is much warmer. By the time that you reach the top of stratosphere, you might experience a temperature of even 0 degrees Celsius. Because remember, at the bottom, you had a temperature of minus 70 or minus 80 degrees Celsius. So there is a rise of temperature by close to around 50, 60, 70, 80 degrees Celsius, depending upon which season and which part of the planet we are talking about. So here, that is what is experienced in the case of stratosphere. So if we have to talk about it in the case of the conditions of change of temperature or rate of change of temperature, I know I'm treading a risky path, but if let's assume somebody puts a gun to your head and tells you that, no, tell me how the rate of temperature is rate of change of temperature is happening, and if you have to come to a conclusion, so here the temperature is actually increasing with height, isn't it? So rather than reaching at a conclusion, let us not risk it at all. So when the temperature increases with height, what do we refer to it as? We refer to it as a negative lapse rate. So that is why in the region of stratosphere, we can say that here you experience negative lapse rate. Negative lapse rate. Okay. Now, the tropopause, if you consider that layer, right? Let's consider tropopause. Above it, you have stratosphere. Below it, you have the troposphere. Now, this is cold and this is warm. So, again, if somebody again puts the same gun to your head and asks you the question, ideally you would expect that person to ask you easier question that, okay, where did Mahatma Gandhi go to launch his first satyagraha, or who is the Prime Minister of India? But let's suppose that person is mad enough to ask you that what will be the temperature in tropopause. Thereby, can we not say that in this region of tropopause, there is a maintenance of temperature? Because there is warming from above, cooling from below. So that is why in the region of tropopause, we have no change of temperature, change in temperature, and again, without risking anything, this is referred to as zero lapse rate. Okay. Now, in situations, now for a brief moment, try to erase everything from your mind. Let your mind be blank for a moment. Now, it might come as a surprise, but then let's assume that you don't know anything about what we have talked till now. When we talk about air parcel and a layer of air, if you have warmer things at the lower portion and colder things at the top, so natural tendency will be what? For the warm thing to rise up and the cold thing to sink down, isn't it? So when you have warmer things at lower portion and colder things at top, the natural propensity or the natural tendency will be a vertical motion, a kind of a mixing. What in many other words or many other languages we refer to it as the process of convection. I hope that is clear. So can we not say that whenever we have the positive lapse rate, there will be convection, right? Warmer things will try to rise up. But what about a situation where the warmer things are already at top and colder things are at the lower portion. There will be no vertical movement because warmer things naturally they are upwards. So that is why when we talk about troposphere, there is a greater vertical movement of air. And when we talk about stratosphere, there is almost negligible vertical movement of air because naturally you will have warmer things which are on the higher elevation. That is the reason why you will observe that large commercial jetliners, the large commercial jetliners, when I say, I don't mean the normal domestic aircrafts that you see on a daily basis. I mean to say the larger ones, the A380s, the 747s, and the 777s of the world. Now, all these, which are very, very large. So, all these aircrafts, when they move in the region of troposphere, many of the times it is that vertical motion of air which they hit. And this aircraft, when it is flying, when it is hit by that vertical movement of air, what happens? There is turbulence. But if they were to fly in stratosphere, then will they experience the vertical movement? No. So this is the reason why large commercial jetliners they fly in stratosphere. In the lower regions of stratosphere, that is where the intercontinental flights that you take, for example, from let's say India all the way to Berlin, or from let's say India to United States, all those larger aircrafts tend to fly in the region of stratosphere in order to avoid that turbulence. This is a question which UPSC had asked. UPSC had asked this question in the prelims, that why do larger aircraft fly in the region of stratosphere? So that is what I say, that the questions which are asked from this area, they are mostly conceptual. You know a concept, UPSC will twist that concept and will ask you a basic question out of it. So that is where your conceptual clarity should be at point. Then we come to the layer immediately above stratosphere, and that is the layer of mesosphere. So when we say mesosphere, here again, we are moving away from the ozone layer. We are moving slightly away from the ozone layer. Ozone layer is the one which is heated. So we can say we are moving away from the heat source. So in this case, again, moving away from the heat source. Preetham, stratopause will also indicate the same phenomena as the tropopause. I'll tell you the reason why. So in the region of mesosphere, you are moving away from the heat source. So what will happen? There will be cooling. So as a result of this cooling, the temperature starts decreasing with the increase in altitude, and the temperature can drop back to around minus 100 degrees Celsius by the time that you reach 80 kilometers above the ground surface. That is the aspect of mesosphere. Right? Now, again, consider stratopause. So here you have mesosphere. Mesosphere is what? Cold. Then you have stratosphere. Stratosphere is what? Warm. Now, in this, when we talk about stratopause, that will indicate a kind of a zero lapse rate. Okay? Now, above mesosphere, the particles, the molecules, they are randomly distributed. You might find that few of the molecules, they are very, very far away from each other. So that is when above mesosphere, you have the density of air reduces significantly above it. And that is when the heating of the sun is received unadulterated and you have the X-rays of the sun emitted by the sun, etc., they also manage to heat up a molecule particularly, and that molecule gets in a very excited state. So that is why above it, again, in the region of thermosphere, the temperature begins to increase ever so slightly. But then above the region of mesosphere, something more interesting happens. And that is where the molecules of oxygen, the molecules of nitrogen, they get into an excited state because of the energy received by the sun. So, when these molecules get into an excited state, they lose an electron or they gain an electron. As a result of that, you have the normal air molecules of nitrogen and oxygen, they turn into a charged particle. So let's suppose something loses an electron. It will gain a positive charge, or a particular molecule gains an electron. It will develop a negative charge. So whenever you have these molecules which are present higher up, they experience an unadulterated incidence of solar light, solar radiation, and because of the influence of that solar energy, they get into an excited state. And that is when they develop electrically charged particles which are referred to as ions. And the entire region extending up till a height from above mesosphere up till a height of around 400 kilometers, that is what is referred to as ionosphere. So ionosphere is the region above mesosphere. Within thermosphere, you have a layer where the electrons, they get into an excited state. So that is ionosphere. Now, why do they get into excited state? Because of the energy received by the sun. So that is where they form positive, negative, etc. Charges are developed. And these charged particles, they significantly allow or facilitate the reflection of radio waves. So the radio waves that you have, they are reflected by these charged particles. So that is where the ionosphere also manages to facilitate radio communication, which oftentimes does happen, right? So that is the perspective of ionosphere. It extends beyond the region of mesosphere. And again, I will tell you, why is it that you have particles which are charged? Because of the presence of solar light and the high amount of solar radiation which is received. As you come into the lower layers of atmosphere, the amount of solar radiation will reduce naturally, but in the higher layers, that amount does not reduce naturally. So that is why you have the presence of ions, and it all constitutes ionosphere. Now, then we come to, what do we mean by insolation? Now, insolation, by the way, from this area, the questions that have been asked have been multiple, manifold. So, as and when we proceed, we will be discussing the PYQs from the layers of atmosphere. It is relevant for your examination perspective. It is significantly relevant for your examination perspective, both for your prelims as well as for your mains exam. When we handle the PYQs, you will get an idea about it. Then we have the factor of insolation. What is an insolation? So insolation is basically the amount of solar radiation which is received at any particular given surface in a given time period. So what is the total amount of solar radiation which is received by that area? That is what gives you an idea of solar insolation in general. Now, insolation can vary. Now, please understand, insolation is very different from temperature. Okay, insolation is different from temperature. Insolation and temperature, they are not the same. This is the amount of radiation received. Radiation received. Whereas when we talk about temperature, indication of amount of heat present. Okay. So it can happen that in an area there is a greater insolation, but the temperature does not increase. So that is a variable amount. Now, if we take purely a look at insolation in itself, it is the measure of the solar radiation received. Now, this can vary. So, insolation varies or is dependent on certain factors. So there are certain factors due to which the amount of solar rays received in an area as compared to the other area, it can be variable. For example, angle of inclination of Earth on its axis, the revolution of Earth in an elliptical orbit, whereby at some point of time Earth is farthest away and at some point of time Earth is closest. Then the configuration of land, which basically indicates the direction in which the land is facing. Okay. So whether if you have a mountain slope, whether which side of the mountain slope is directly facing the sunlight. So that also ends up determining the variation in the amount of insolation, and also the factor of altitude, that is height. At what height is a place situated? A place which is situated at a greater height will always receive greater solar insolation. So when we take a look at all of these, basically angle of inclination of Earth on its axis is at an angle of 23.5 degrees. That is the rate at which the Earth is inclined on its axis. Now here, if you will observe, if I were to tell you, for example, suppose I will give you the same example of the torchlight. So here, you have the torchlight which is falling on the surface. And conversely, let's assume I have a torchlight at a tilted position. Now, if I were to measure the intensity, now intensity is more distributed in the case where it is tilted, and intensity is more concentrated in this portion, isn't it? Intensity is more concentrated when the light is direct. Intensity is more tilted or more distributed when it is tilted. Okay. So what do you get as a result of that? So wherever you experience direct rays of the sun, there the insolation will be more. So for example, here you will observe that the sun or the solar rays, they cover a much shorter distance. And in this case, they cover a much larger distance. So that is when those areas where the light is received directly, we say that the regions closer to the equator, they will receive higher insolation as compared to the higher latitudes or closer to the poles. So that is why we say insolation received at equatorial regions is much higher as compared to the higher latitudes. Okay. Then when we talk about the revolution of planet around the axis, we do know that we have the condition of perihelion and aphelion. Perihelion when when the earth is closest to the sun, aphelion when the earth is farthest away from the sun. We have these conditions, don't we? So when you have the earth which is closer to the sun, the amount of insolation is slightly greater. Insolation is slightly greater. Even though the impact on temperature in these cases is not felt because of the influence of the atmospheric circulation and so on, but we can easily say that insolation is higher in the conditions of perihelion as compared to conditions of aphelion, right? Now, then another factor which leads to a variation in insolation is the direction in which the land is facing. For example, here if I give you the example of it, mi refers to miles, Pritam. So here if I give you the example of it, let's suppose this is the planet, and let's suppose here the sunlight is coming from. Here you have the equator. The planet is slightly tilted. So let's suppose this is the equator. Now, if I consider a mountain in the northern hemisphere, this mountain will have a northern face and a southern slope, isn't it? Now, if I were to ask you that out of the northern and the southern slope, which will receive direct amount of sunlight, what do you think will be the answer? Which will receive greater amount of sunlight? The southern slope always, because it is facing the sun. Similarly, in this case, if I tell you that I have another mountain like this with a northern face and a southern face, which will receive greater amount of solar insolation? In this case, the northern face. So depending upon the face of the mountain which is facing the sun, that will always receive greater amount of solar insolation. In this case, the northern face. So that is why if you will take a look at this image, so in the southern hemisphere, you will always observe that the north facing slope generally receives greater insolation. In the northern hemisphere, south facing slope receives greater insolation. That is why in the region of Himalayas, when you consider, in the case of the Himalayan mountain range, always you will find that the southern slope of the Himalayas, they will experience greater solar insolation as compared to the northern face. That is why across the southern face and the southern slope of Himalayas, temperature is much more tolerable as compared to the northern face. And that is why the southern slope is densely populated as well. With altitude, with an increase in altitude, with an increase in height, the amount of solar insolation received is greater. Why? Because when we talk about the height, so above it, if you have atmosphere, when the solar rays, they come in, let's say this is the altitude, this is present at a height of 3 kilometers. So overall, the solar rays have to pass through a much thinner layer of atmosphere while reaching that altitude. So that is why closer to the ground, more atmospheric particles come in the path of the solar rays. That is why solar insolation is higher as one moves up with altitude. So insolation is how we have, or insolation is varied because of these factors. Okay, so that is where we'll end the session for today. I hope, if nothing else, I hope the rate of increase and decrease of temperature is something which is clear in your life right now. And I hope you will write it down somewhere that vapor retains heat in general. But on a serious note, everybody who has got any slightest amount of confusion, do feel free to contact us, write to me as well. You can get to me and we will get back to you in detail. And ideally, I would advise you that have a good command of class 6 to 8 science. That is something which will help you understand many different topics. So with that, I'll end the session for today. Okay, angle of inclination, Karti, is basically the angle of tilt around the axis that you will observe. So because of that angle of tilt, as you will observe, the solar rays, they fall at different angles. Closer to the equator, you will observe they make very high angles. Closer, in certain conditions, they can be perpendicular as well. So whenever it is perpendicular, there is greater intensity. When you come to the higher latitudes, lesser intensity. Okay. Does ozone layer lie between the stratosphere? Yes, Devansh. Within the stratosphere, that is where you have the ozonosphere. And Amuthayani, can you again say about ozone layer? That is what is the presence of ozone layer, and it is constituted of ozone molecules, that is O3. The related aspect about depletion, etc., you will cover in environment. Okay. Yes, the weekly test will be available this week. Nandamuri, typically in the southern face. Nitrogen particularly does not have a lasting impact or a direct impact on the atmosphere. Subjective tests, Shamil, you will get, not objective questions. Okay, so we'll end the session here today. We'll meet again on Monday, and that is when we'll continue from here. We'll get into the portion of pressure.